he won the Engstrom Science Award. He actually worked for, was a colleague of Walter Cronkite's. He consulted for NASA, where his picture still hangs reverently in the halls of Houston, the Ames Research Center, and lots of other locations around NASA. People actually have been said to salute the photograph in NASA as they walk by. Richard C. Hoagland.
Good morning, Art.
Hey, Richard.
Welcome back.
Well, thank you. I had a good time in Paris.
You know who else went to Paris to take a rest from their heavy labors?
Who?
Ben Franklin and Thomas Jefferson.
Really?
Yes.
Well, it is such a complete change of worlds from, the desert where I live to Paris, which is old and filled with statues and, the feeling of old, that it's kind of fun. It's just getting away,
And when Graham's new book comes out, Graham Hancock,
yes,
together with Robert Laval, we're going to find out some very remarkably intriguing things about Paris.
Really?
Yep. There's some major surprises in Paris that are connected to all the stuff that we talk about.
No kidding.
In fact, up to and including Mars. But we're going to have to wait till they come out with the book because I don't want to, steal their thunder.
All right. We've got an awful lot to cover tonight. And the first thing I want to ask you about, I have been bitching for 2 weeks now. I've been getting story after story after story, Richard, that the Japanese, well, they've already launched a probe to Mars, and they're talking about a manned mission to Mars. And when I heard about the probe to Mars, I said to myself, what the hell are they doing? We've sent probes. The Russians have sent probes. Now, why would they spend very scarce, undervalued yen, with the Asian crisis going on, to send a probe to Mars to duplicate, no doubt, what we have done or the Russians have done? Why are they starting a space program?
You mean an interplanetary space program?
Yeah.
Dimensions. Yeah. Well, these are all exquisitely interesting questions, and the most profound question no one is asked because they're not into the arcana of spaceflight the way some of us are. The real mystery, Art, is not why they're going, but why they're going early. It's kind of like that joke about the drunk, who loses his keys, and he's searching around under the street lamp, and the cop comes by and he says, what are you doing? And the guy says, I'm looking for my keys. And he says, where'd you lose them? Well, over there, and he points out in the dark. And the cop says, well, why are you looking under the light? He says, well, the light's better over here. The Japanese have launched, Art, 5 months early.
Really?
You can't get to Mars until December. The spacecraft is not on its way to Mars right now, tonight, at this instant. It is somewhere circling the Earth.
In other words, they've got it circling the Earth, waiting for the window to fire it off.
Exactly.
Why?
Which has never been done in the entire history of any space program of any nation on this planet.
Exactly. Why would you want to risk, for example, the possibility of a collision in Earth orbit with some piece of junk or something?
Well, think what's going to happen in November. There's been an alert in Aviation Week and in a lot of the major satellite manufacturers. We're going to go through a meteor shower.
Oh, I know.
And everyone is forecasting pretty hairy stuff for the communication satellites. You may go off the air because
I know.
One little grain of sand impacting at 26 miles per second, which is the parabolic velocity of meteors at the Earth's orbit,
would ruin the day of one of my satellites.
Would definitely give you a bad hair day. So why would the Japanese launch and then wait in Earth orbit? They're in this parking orbit going around and around every 90 minutes or so for 5 months because they can't launch out of Earth orbit on the right geometry to get to Mars until December. Never has been done. And in all the discussions that I've heard, and we've never talked about it because it was so mind-boggling that I kept looking for an explanation. I have been unable, as of tonight, to come up with any rational explanation. The best thing that I can propose is something that Ron Nix, one of our geologists, proposed to me, a couple days ago. He says, well, Dick, it's obviously the physics. They know something hyperdimensional that you don't. It's almost as good as any other because it makes no sense. Now, there is one possibility which is so astonishing that I kind of hesitate even to broach it.
Oh, broach it.
But suppose you kind of had a probability estimate that your launch site might not be there when you need to launch. Japan is very earthquake prone, right?
Yes.
The safest place, if you have to go to Mars, for reasons that we can get into later in the morning, would be to park it in space, waiting for when you can send it on its way. If you may not think your launch site will be there when you need to launch. That's the only thing I can come up with that makes any rational sense. And even that is so amazing because it indicates that somebody thinks maybe Japan is in for a very rough ride.
So you're suggesting they may know that their launch site may not even be there or might be in rubble?
Well, might be, shall we say, in jeopardy. Remember Hurricane Andrew when it was heading for Cape Canaveral?
Yes.
And how they battened down the hatches and put the Mars Observer on backup power and all that?
Yes.
Well, Cape Canaveral was not earthquake prone. But imagine that you had Cape Canaveral on an island where earthquakes are becoming increasingly severe and are changing depth, underground in the mantle, coming up toward the crust.
Right.
You might, if you knew something about the trend curve of this thing we all call Earth changes,
yeah,
and we're predicting out the model, that there might be a reasonable probability that a severe quake could so damage your launch site that you could not launch on time. In which case, then the estimate and the calculation would make perfect sense to put it in Earth orbit, where it is safe if that's what is being projected. Or safer, I should say. In other words, something is really extraordinary, not just about the Japanese interest in Mars, but the fact that they have to go, and they've launched 5 months early.
All right, but even all of that said, Richard, why go to Mars to spend a very scarce yen on stuff that we've already done? What are the possibilities there?
Small to zero. I mean, this data, as you know, is shared freely and has been shared freely even during the height of the Cold War. We were sharing our space data with the Russians, and they were sharing their Venus data with us. And
don't they trust our photographs?
Well, that does raise an interesting set of ideas, doesn't it?
Yes, yes.
Now, one of our listeners faxed me a couple of days ago, and I don't remember their names, but someone heard a news story, apparently from Japan, either the day of the launch or a day after the launch. It was kind of a translation over the Japanese video of the launch.
Yeah.
And the announcer was talking about the reasons for going to Mars was to study the atmosphere and the underground structure. And these people very intriguingly thought that might imply artificial structures. I, in fact, think it's probably a poor translation of in other words, subterranean mascons and gravity variations and all that, because you can get a lot of data from just mapping the orbit in terms of underground concentrations of various kinds. And our own spacecraft are, in fact, looking at those kinds of gravity anomalies to refine the map of the lower mantle structure or the upper mantle structure of Mars. So I don't think that translation really implied what they thought it might imply. But again, the whole idea of the Japanese trying to go and duplicate what we've already done, I mean, why not go to Mercury or go to Titan or someplace that we haven't gone? Why go to Mars?
Well, if I were Richard Hoagland, I'd say because they want the photographs and information that they don't think we've made public and haven't given to them either.
Well, let me give you another data point on that side of the ledger.
Otherwise, why do it? It's very expensive. Look, we're at a break point. If you're going to give me another data point for the ledger, hold it until after the break, all right?
Can do.
All right, stay right there. Why are the Japanese doing? Just doesn't make any sense. Anyway, this is Coast to Coast AM. Well, all right, back now to Richard C. Hoagland outside of Albuquerque up in the mountains where he is a recluse. Richard?
I am in a gorgeous mountain desert tonight. There is a quarter moon rising over the Sandias to my east, with Jupiter hanging about 5 degrees to the upper right, about the 2 o'clock position. The clouds are scudding across. The stars are bristling, and it is breathtaking.
Well, I only say that because of where I live, where I choose to live, they call me a recluse, and so it's just really annoying.
Well, in the days of the Internet, it's no longer possible to be a recluse or having phone lines or fax lines.
Actually, you could look at it the exact opposite way. Now with the Internet and all the rest of technology, it is possible to be a recluse. In other words, you don't physically have to go anywhere. It all comes to you.
All comes to you,
yeah, that's right.
Including people. In fact, this is a really elegant segue into what I was going to do before the break. Yesterday, I had an old friend of mine who was an optical and acoustic engineer drop by, who's been part of our project for several years. He just appeared suddenly out of nowhere on his way back from the East Coast, driving back to Los Angeles. More people have stopped by this mountain since I've been here.
That's right, I'm sure they have.
It's amazing the number of people who come to visit.
Listen, I want to pass along a quick message that comes to you from everybody in the Grassy Knoll. That's a chat room on AOL. Mm-hmm. It says, on behalf of everybody in the Grassy Knoll, Richard Hoagland is under a sentence of death, life, or whatever we can give him for every answer that goes any longer than 2 minutes.
The Grassy Knoll chat room, okay.
Yeah.
Anyway, John stopped by, and we were discussing Mars.
Right.
This is why it's a segue. And he pointed out something very intriguing and very disturbing, which gets back to why the Japanese may not trust us. Remember during one of the early shows when we were talking about the April 5th photos, and we were matching the fingerprints on the raw data?
That's right.
Those long, narrow lines going all the way down the 26-mile strip.
Sure.
That are kind of like the, scratches on film of an old Betty Grable movie or something.
Sure.
Well, John pointed out, because he deals with this technology on a commercial basis. That's one of the companies that he runs. And he deals with state-of-the-art around the world with telecinis and whatever. And he knows the people who make these line scan CCD arrays, which is the heart of Dr. Malin's camera. And he pointed out to me something that, frankly, had not really occurred to me, which was we shouldn't be seeing any lines at all, because the defects in the original manufacture of these camera systems have now been so radically reduced that the difference between one pixel and the adjoining pixel is like 0.001% or something. In other words, you wouldn't even see it. Certainly you wouldn't see it in the raw data. And so he got very disturbed by seeing it in the raw data and even in the finished data on some of Malin's images from other parts of Mars on Malin's own website. And he went through a scenario with me that frankly made my hair stand on end, because it's one more level of what are they really doing to us? How are they really jerking us around? Because it is his contention that this is a second-level set of evidence that the images we've seen of Cydonia are not raw data, that they have been cooked. And what he said could be done, and he explained to me how this could be done, and I said, well, you've got to write a paper on this, and we'll put it on the web. He said that what they could do would be to basically take that camera and image a kind of a blank. And then, because of the way the scan works, it would register those CCD imperfections much more than the background. And then, like in Photoshop, you could layer that scan over the actual picture, which would have the effect of blurring and suppressing the real exquisite detail we'd like to see down on Mars.
Right.
And leave the impression of the CCD fingerprints, because that would be part of the process that you couldn't get rid of. And when he went through this to me, I looked at him and I asked myself, I asked him, John, there's got to be more than two people in the whole country, or 260 million people, that know this. To which he had a very short and very elegant answer. He says, yes, there are. And they're all working for NASA. The point is, you have a very limited technical club, Art, of people who are in the know on something so arcane. I keep using the term priesthood, and it's more than a metaphor. Because when you have people all feeding at the same federal trough for very scarce dollars, the bright guys that are looking at this and saying, uh-oh, they're not going to say anything in public. They're not going to come forward and corroborate what we're talking about right now, because if they do, their contracts go out the window tomorrow.
Has NASA yet made any definitive statements with regard to the Cydonia strips?
No.
No.
But what we're getting from our sources is that inside there is the most interesting war going on, intellectual war,
Inside NASA?
Inside NASA, among the honest crowd. Remember, I have always clearly divided NASA into two segments. The tiny handful of suppressors, the folks that simply don't want us to know. And then the majority of the agencies, of the 20,000 people who go to work, who believe in the God, American pie, and the flag, and basically believe what I used to do, which is NASA's neatest thing is sliced bread, that it was an incredible asset to the human condition. And they still believe that. And those folks always thought, because they had been manipulated by the suppressors over the years, over 20 years, as documented by McDaniel in his former incarnation, to believe that Cydonia was nonsense, that we're crazy, that Cydonia is just a pile of rocks, etc., etc. It's those people looking at even this altered data from Cydonia on the 3 passes in April, who, according to our sources now, are really at loggerheads, because they can see things on these images that are not geological, not natural, not explicable by any processes they understand, and they are absolutely terrified because it means that A, is going to have to confront the artificial hypothesis square in the face, unintended, and B, there's a huge political problem because if they were to do this in public before November 8th, then Bill Clinton might wind up losing the chance of regaining Democratic control of the House and Senate. The Republicans, all right, to go to the other side of the fence, they don't want this to come out before November 8th because they might stand the chance of losing control of the House and Senate. So everybody is kind of in frozen mode.
Yeah.
And there's going to be nothing happen until after the election.
Well, here again, Richard, this honestly is the only reason I can imagine the Japanese are expending incredible amounts of money to send a mission to Mars, and it's because they don't believe what's come from us or what's come from the Russians. What other possible reason could there be?
I think, if you want me to say the obvious, I think you're absolutely right. And I think that it is so important that given the possibility that an earthquake in Japan, in the Ring of Fire, might damage the launch site, they have gone to the extraordinary lengths of putting this spacecraft in Earth parking orbit where it has a reasonable probability of lasting, because things in space do tend to last a long time, till they can send it to Mars.
Yeah, but this indicates a certain desperation to get there.
No. It indicates a certain urgency. In other words,
urgency.
we have always said, those of us that have been on this trail now for 15 years, in fact, I said it on the back of the Monuments of Mars, the work that I wrote to describe this investigation from the beginning. I said either these images are a complete waste of time, or this is the most important discovery in the history of mankind. There's nothing in between.
Yep.
And obviously now you know where I think we should vote. Well, it looks like the Japanese are agreeing with us. About time somebody agreed with the nature of what we've been discussing. And Graham Hancock has come on board with his new book, The Mars Mystery. And others are slowly coming around. I mean, I saw great quotes in Graham's book from Mark Carlotto, where for years he'd been sitting on the fence. And then he, took a new look at all this data, including some of the early work that we did, through a methodology called Bayesian statistics. And, he used to be kind of a fence sitter. He'd say, well, it's 50-50. Now he's saying it's like 90-10. Dr. Van Flandern, Tom Van Flandern, who is no slouch when it comes to thinking, he's giving odds now. When he came to the University of New Mexico to do our seminar here a couple of weeks ago, he was giving odds, you better hold on to your seat on this one, of 10 to the 31 to 1 in favor of intelligence.
Brother.
That's 10 followed by 31 zeros.
In favor
of intelligence. In other words, it's a lead pipe cinch. There is no way to escape from the fact that Cydonia is artificial, period, end of discussion. Let's move on to what the hell does it mean. So the fact that the Japanese are sending a mission, and are talking manned mission, and are sending a mission 5 months early to put it in parking orbit so they absolutely, positively can get this thing launched in space in case their launch site goes away, is some indication, maybe, finally, that somebody beside us crazies thinks this is important for the human condition. Or at least Japanese condition.
Look, with regard to our origins, there are fewer important questions, maybe whether there's life after death, and we may find that out when we know more about our origin, so it could all be answered at once. It's an important question, and I can understand the Japanese feel that way about it. So anyway, it was a mystery, and I had to ask you about it. Here's another little item for you. As you know, there were movies recently, Deep Impact, then Armageddon, and now a UPI story in front of me, dated July 14th, today. A new NASA program to detect, track, and characterize potentially dangerous asteroids and comets that could approach Earth is being set up at NASA's Jet Propulsion Laboratory in Pasadena. NASA's Near-Earth Object Program Office will try to locate at least 90% of the estimated 2,000 asteroids and comets that approach the Earth and are larger than about 2/3 of a mile in diameter by the end of the decade. So now, all of a sudden, they're in a big rush, Richard, to identify at least 90% of these, which was no big deal. What are we to imagine? That Deep Impact and similar end-of-the-world movies have driven NASA to suddenly cut loose the money to do this, or what?
Well, I have a more complicated scenario. I began watching this whole asteroid mania, or meteor mania, or comet mania, at least a year ago, with a series of specials that appeared on every major network simultaneously, all within a week. TBS, CNN, NBC, the Sci-Fi Channel. You know, I'm not being exhaustive, but all of them ran, and I have taped copies in the archives of all of these specials that hit within a week, following on print media. The London Economist a couple of years ago started with a cover story in The Economist, of all things, with a large picture of an asteroid and a spaceship floating next to it that was actually a painting by Chesley Bonstell that I, many, many years ago, helped design. I mean, there's a long story. We won't go into that tonight. But it's like suddenly there was this gestalt. And after being ignored, after Gene Shoemaker and his work for years and years and years had been ignored,
yes,
suddenly, simultaneously, on all available outlets, there was this dawning awareness, culminating with a very dramatic dramatization of a news station broadcasting a live interrupt from the Pentagon of a couple of asteroids hitting somewhere over Scotland and England.
Yes.
Airbursts. And then the call letters of the station, by the way, were WENN, when. And this went through, and ultimately you had a gal named Shannon something or other standing in front of New York City,
yes, describing
the impacts coming across the Atlantic, and the solemn voice of the head of Space Guard, which was supposed to be one of these asteroid warning centers, intoning on air that it wasn't random asteroids, as the Pentagon was saying, it was pieces of the tail of Hale-Bopp, and that we were passing through the tail, which in fact does occur now every January 3rd, and that it was those pieces that were raining down and were going to cause untold havoc and destruction. And just as they cut to the reporter standing in front of New York City, there's a huge airburst, and she and New York disappear in a fireball of flame, and the whole thing goes dead. So I'm looking at all this, and then, of course, we have the announcement of Spielberg's movie Deep Impact, and then we have Bruce Willis doing Armageddon.
Yeah.
And it doesn't take a rocket scientist, Art, to say, does somebody maybe know something?
I really do agree with that. I mean, I have come to be a believer in synchronicity. And
well, I'm a believer in leaks. And a believer in leaks for those who are in the know.
You think somebody in Hollywood had a sit-down meeting with somebody way high up in government, probably even higher than the government we've elected, and they said, look, you're going to have to start doing some movies about the possibility of something from space, because...
Well, we had the scare from Brian Marsden, my good friend at the Smithsonian.
Well, I mean, there's another data point, as you would like to point out, usually.
Yes.
Yeah, in other words, they said, well, here's something that may hit in whatever it was, 2048 or whatever. Yep. And for a day or so...
it was revised.
Yeah, but for a day or so, we thought maybe that's it.
That's right. Now, remember, a few weeks ago, we had a remarkable announcement, which was that if, in fact, an asteroid or comet or something is identified on a collision course prior to impact,
right,
they're not going to tell us.
No, as a matter of fact, after that 2048 announcement, NASA sent out a memo to all organizations that get any NASA money that anybody who announces something coming at Earth early, they want 72 hours of delay. Anybody who announces it any earlier than that loses their budget.
And, of course, given the uncertainties and the sketchy sky patrols and the lack of money up until this announcement out of JPL, most of the warning you'd probably get would be in the order of 72 hours. Now, if people were alerted, given that most of the stuff that would get hit by is small enough that you could safely get out of the area, you'd want to give some people some warning to leave. At least you would think that someone would want to give somebody warning so they could leave. In other words,
well, it's a mixed message. Let's say it was going to hit Los Angeles. I'm tired of picking on New York. Let's say it was going to hit L.A.
Okay.
Even with the great highways and so forth they have in L.A., they would probably compute, depending on how big the object was, that there would be more people killed in the panic trying to get out than might be killed by the object.
Well, given that a small object, a few tens of feet across, would be the equivalent of a 30 to 50 megaton airburst, and that would effectively eliminate several million people. Even in an all-out mass panic, you're not going to kill several million people, so the numbers there don't wash. But this is all the downside. The good side is, and this is what I want to talk about tonight, I have just published on the web this very extensive 50-page hyperdimensional paper.
I know.
And I want to go through how what's in that paper and what we already know exists makes this problem, this asteroid impact or comet impact problem, moot. This is a false problem. We are being diverted by somebody from looking at real problems with a false problem. And when we have more time after the top of the hour, I want to go through what we can do.
All right, well, I will say this much, and that is, hold on, Richard, that those who have read Richard's paper have declared it to be a sound, scientific, easy to understand, well-written paper. It's on the web now, and if you would be so kind as to, for all the other reasons, go up to my website, which is www.artbell.com. Scroll down to Richard Hoagland's name, jump across to the Enterprise website, and read some of it. Let's see what you think. I am told by those who have read it that it is good, well-written, sound, and scientific. So, with that, Richard C. Hoagland back when we are. We just had an announcement today that the last 6 months of weather has been the hottest in the recorded history of the world. Paul, who is in Dallas, writes, "Hi, Art. We're burning up here in Dallas, even with the window air conditioner on. As a matter of fact, in Texas now, there are over 20 dead with the high temperatures. Out west here, the temperatures are also absolutely outrageous." Richard, do you have anything to say about this weird weather that we've been having?
Yeah. I mean, that's one of the reasons I wrote this paper. As we said on the last show we did, when we talked about the hyperdimensional physics model, for many years, since actually the late 80s, 88, 89, when Torrin and I figured out the geometry of Cydonia and then compared notes with Stan Tenen, and Stan pointed us in the direction of some of these hyperdimensional models which have existed in the mathematical literature for over 100 years.
Right.
I have wanted to put together the meat on the bones to really, put teeth into the idea that all of these weirdnesses, all of these strangenesses, all of the things that people are talking about, that you talk about, that listeners call in about, that various guests talk about, all have a coherent theme and could be explained by an appropriate model. Now, I never imagined that it would be the hyperdimensional model that would ultimately wind up making very specific predictions and probably is going to be the explanation that ties all this stuff together, but that looks like where we are going. So while you were in Paris, in fact, even before, I sat down and finally did what I've been threatening to do for 10 years, and I put together a very comprehensive 50-page with all the links and references, including to our earlier work, the Message of Cydonia paper, which is also on our website. And we put that out there now to basically let everyone, both technically literate and technically non-literate alike, have at this model and look and basically critique it to see if it makes sense. And what it does, Art, is it pulls together a lot of these disparate threads, and it makes very important predictions, among others, regarding the weather, or climate. We should actually talk about climate, because that's the long-term trend of weather.
Right.
And geophysics, or Earth changes. And what we tried to do is to back up the hot-button issues that everybody talks about, weather and earthquakes and stuff, with a lot of other data that is more subtle and more technical, but is equally critical, equally important. And I've had a range now of feedback from physicists and astronomers. I mean, even Tom Van Flandern, who is, as I said earlier in the show, an exquisite thinker, a pioneer in his own right, who does not see eye to eye with me on everything. And I pride myself that he and I respect each other enough that we can disagree. We can agree to disagree.
Right.
He called me up, and he said, first of all, he says, I need page 12. I'm missing page 12. So I promised to send him page 12. The second thing was, he says, I'm not convinced, but I'm very impressed. And he says, damn it, it's really getting to me. This is interesting.
Yeah, I've got to say that that's the response I've been getting, too. I've had a lot of emails and faxes, Richard, from people who say it's a very cogent presentation there. And while they previously have not understood altogether what you were saying, they do now. So it's quite well written, I guess.
Thank you. And again, what I'm looking for are both technical feedback from physicists and astronomers, NASA physicists and others who will know the minutiae of what we're referring to, and who will be able to read some of the links, like Whittaker's papers, that for the first time in almost 100 years, except for Tom Bearden's publishing of them, have seen the light of day. These are papers that literally, almost 100 years ago, united gravity and electromagnetism in a way that everybody thought Einstein did. But he was not the first. Maxwell and then later Whittaker were actually the first to really do this. And many other technical aspects of this. I want technical feedback because...
Okay, well, listen, but for the layman, when we begin to see all this volcanism, and there's a lot of it going on around the world right now...
There is.
The latest being the earthquake a couple hours ago at Mammoth. And we see this incredible, profound weather change. I saw pictures of crops earlier tonight on CNN in Texas that were burned literally to a crisp. I mean, they simply don't exist. They're gone. Why? What's going on?
Well, the Gore model, Al Gore,
yes.
Vice President of the United States,
yes,
is taking his cue from the experts that are talking to him at NASA, at NOAA, various agencies like that. And they're basically saying, okay, Al, this is global warming due to fossil fuels. All right? The bigger view is that may be a small component of it, but it can't be affecting the weather on Mars. It can't be affecting the weather on Titan. It can't be affecting the weather out on Neptune. There is a solar system set of changes, which if you follow the literature... Okay,
are you saying that there are similar changes taking place on Mars, on Titan?
Yes. And they're cyclic. As I point out over and over again in this paper, the hyperdimensional paper on the website, the key difference between the hyperdimensional model and all the other models is the hyperdimensional model predicts variability. Very strong variability, both short-term and long-term. So you will have a trend where it will get very, very hot for a while. And then it will change and it will get very, very cold. The El Nino, for instance, if you've been watching the NASA sites, in 1 week, they went off the Galapagos from El Nino conditions, very warm, very desert-like conditions around the Galapagos.
Right.
And in 1 week, they went to cold water where they've had algae blooms that are the greatest they've seen in 100 years. 1 week. Now, geophysical changes normally take place over, years or decades.
Very slowly.
Or very slowly.
Yeah.
A characteristic signature of the hyperdimensional model is very short-term changes because this stuff is not normal thermodynamics. It's changes in the way heat is actually exchanged between atoms and weather systems and volcanoes and the mantle of the earth and the surface and processes that are explainable by long-term processes don't apply to these processes. So the prediction is you're going to see a lot of very rapid changes in all kinds of things that are unprecedented because the long-term model, our model, says we're entering into a period in the whole life cycle of the solar system where things are going to get a lot more interesting, a lot more chaotic, a lot more changeable, and the short-term effects will be weather, hot, cold, changes in jet streams, changes in weather patterns, changes in everything.
Do you have any sense of timelines? I mean, we are mortal beings,
yep.
And I'm used to the thought that these changes are, occur over millions of years, not a couple of years.
Okay, let me give you some specific data that's not in the paper, because if I put everything we know in the paper, it would have been a book.
Sure.
In fact, it will be a book. This is going to be a good chunk of the next book, the sequel to The Monuments of Mars I'm trying to write.
Okay.
So it'll be a spare time. With a lot more reference, a lot more data. For the last 10 years or so, there have been two major drilling projects going on, both in the northern climates, northern polar regions in the Greenland ice cap, and down at the South Pole. We have been doing drilling, and the Russians have been doing drilling. And they've gone down deep enough, a mile or two, to where they've got about 200,000 years of data.
They pull up core samples?
They pull up cores of ice, and the theory here is that it snows, and then it compacts. And it snows, and it compacts. And so snow eventually turns to ice.
Right.
It eventually turns to very hard ice. And down near the bottom, if you pick the right place to drill, that ice has not been disturbed. It hasn't moved, certainly hasn't melted, in hundreds of thousands or maybe a million years. That's some of the current models, all right?
Okay.
In the ice, there are little bubbles of air trapped. And in those little bubbles of air, they can sample when they bring up the cores and slice them and put them in these cold sheds and tag them and catalog them and all that. They can thin section, meaning they take a little saw and they saw these long cores into fine slices. And then they can basically measure how deep that slice came from, which, based on certain assumptions about snowfall and compaction and all that, it translates to the number of years since that snow saw the light of day. And so then they sample the little air bubbles in that ice at that depth, and that tells them what the atmosphere was doing and the temperature and the climate, etc., at that incredibly distant point far back in time, going back like 200,000 years. And what they found in trying to figure out ice ages, for instance, is that in as short as a year or 5 years, you can go from warm, almost tropical climate to glacial. Overnight. Just like you turn off a light switch. And then it reverts suddenly, just as suddenly. And this, when they found this a couple of years ago, the data was so unbelievable that, of course, nobody believed them. Now they have from both poles enough data to show that not only does this occur, that we can go from very warm to very cold, just like you turn off a light switch, and back again. But unlike all the glacial models that have been proposed for driving glacial cycles, the Milankovitch cycle is the most predominant one, that is tagged to the Earth's orbit and the way it changes ellipticity and the axis of the Earth wiggles back and forth and all that.
Right.
Which predicts that you'd have glaciation in one hemisphere. What they're seeing in this core data from both poles is it's occurring simultaneously in both hemispheres, which none of their models can allow for. The hyperdimensional model easily accounts for that, both in terms of both poles simultaneously and the short time span. Because what the hyperdimensional model is basically saying is that the environment of this planet, of the entire solar system, is basically determined by the changing positions of the planets we know, predominantly Jupiter and Saturn, and now by probably a couple of guys far out there that we don't know yet, that have not been found yet, which move very slowly. And because the farther you are from the sun, the slower a planet moves. You know, Mercury goes around in 88 days. Pluto takes 250 years. The planets I'm talking about, they go around in periods as long as 2,000 years or even 26,000 years for the last one that I'm thinking might be out there. The phase relationships, the time it takes for them to change angle with each other,
yes,
to hit certain of these so-called tetrahedral hyperdimensional angles, like 120 degrees, 60 degrees, 90 degrees, is very, very long time scale. So those would drive the huge cycles. And the inner guys, and I include Saturn and Jupiter as the inner guys, drive much shorter cycles. So you can think of it as you know, if you kind of imagine a big bank of heaters, all right, and somebody's standing by a set of rheostats,
right,
and they're turning the rheostats. And one guy is turning them on a time scale of several days, up and down, up and down. And another guy at the other end of the hall, you know, this huge power plant, let's say, is turning his dial every few minutes, back and forth, back and forth, back and forth. So the big cycles are driven by the outer guys, and then those are modulated by the much more rapid rotation around the sun of the inner guys. So you have cycles on cycles on cycles. And those cycles basically are changing the properties of space-time itself in this model.
Is there any way through this model for you to tell me in the near term what we have to look forward to?
More change. In other words, the long-term trend is you're going to have more available energy, if we're correct. And on that more energy, which has to go somewhere, the phasings of the inner guys, Jupiter, Saturn primarily, will result in shorter-term changes, and the inner guys, Mercury and Venus and Mars, determine even shorter cycles. So you'll have very rapid switches because there's a lot more energy running around in the system, and this energy doesn't just drive weather or the geology, you know, earthquakes and volcanoes. It drives everything.
Yeah, well, the importance of this to us is we actually exist and live in an environment that operates, at least for the human being, on a kind of a thin line. I mean, you can't take very many degrees of change either up or down and expect us to grow crops where we have been growing them, to have large human populations in the coastal areas where they have been, et cetera, et cetera, et cetera. So a very small change can produce a very, very big effect. Are we about to have a very big effect? Or more accurately, are we having it?
We're having it, Art. And unless we get our facts straight and our model straight and our physics straight, there's not a damn thing we're going to be able to do about it. Remember, the first step in affecting your environment is understanding your environment. If you think it's because you're dumping fossil fuels in the atmosphere, and you produce a whole bunch of laws to stop that, and it ain't that at all.
And it doesn't work.
It doesn't work.
Yeah, I have no idea why it's happening. I just observe it is happening.
It is happening, and it's happening on a very short time frame, and that's the key
signature. Yeah, I can see that. I can see that, a very short time frame. In other words, if you can project, and I can in my own mind, that we get as much change in the next 2 years, say, as we have had in the last 2 years, we're going to be in a pretty precarious position.
In the normal course of events, over the recorded history which we've known, all right, the sun has been very constant. In fact, back in the early parts of this century when the Smithsonian was actually measuring...
Hey, Richard, can you hold for a second?
Absolutely.
I'm right up against a time deadline. Stand by. We'll be right back.
Often imitated, never duplicated. This is News Talk 89 WLS.
When I start talking about this sort of thing, the weather changes, the volcanism, the earthquakes, and so forth, I start getting these angry political faxes, people who hate Al Gore or hate the president, which is fine. I don't care if they hate him. But they get angry at me for spreading the lies of those who are saying this is occurring. Now, maybe Vice President Gore is wrong about global warming. Who the hell knows? But the weather obviously is changing. And so I don't see why people are getting angry about that. It's just a fact. It's right in front of us. It's occurring right now.
Well, when you see records broken, I mean, the British Meteorological Office has no hold with, Gore or Clinton or whatever.
I know it.
And there are other people on the other side of the aisle politically. I want to talk about Frances Barwood in a little while.
Yeah, I do too.
Who is very important in bringing to light a lot of things that are now kind of kept in the closet that will provide us solutions. And she's obviously not in the Gore camp. But the point is that this is an apolitical problem. This is neither Republican or Democrat or liberal or independent or libertarian. This is a terrestrial problem. And given that we've been looking at data that's beyond the Earth of outer planets and long-term time trends, to ascribe this to very short-term historical usage of certain fossil fuels or whatever is to miss the point. That we don't know everything there is to know about astronomy and physics and geology and chemistry and all that, and that's why we fund sciences. And what Gore is depending upon is the best input he's getting, which is not the secret black budget input. It is the mainstream, common NASA, what the hell is going on input. And unless there are more models on the table to choose from, you can see the effect, you won't know the cause. And what I'm trying to do tonight is to point at another possibilities for the cause, because unless we figure out the cause, we're not going to come up with the correct solutions.
Is there a solution?
Yes, there is.
Now let us take your hyperdimensional paper at face value and say we understand it, we believe it is so. How can you take what you know and apply it to an actual solution?
Well, it depends on the problem. Remember your friend Michio Kaku?
Yes.
And his wonderful discussion of Type 0, Type 1, Type 2 civilization.
Yes, sir.
Which, by the way, he borrowed from the Russians. It was a Russian named Kardashev who actually first came up with this concept back in the 50s. And his companion author, Shklovsky, I.S. Shklovsky, who wrote a book with Carl Sagan called Intelligent Life of the Universe, where the concept of civilizations being graded according to type, basically according to how much energy they control. That's the mechanism of grading.
Okay.
And I don't know offhand. Let me see if I remember what it was. Type 0 was you control basically, enough energy to run lights on a continent. A Type 1 controls energy on a planetary scale. A Type 2 controls energy on a stellar scale. And a Type 3 controls energy on a galactic scale.
Okay.
We need to go from 0 to Type 1. That's the long and the short of it.
All right. How do we do that?
This physics provides us with mechanisms to alter the behavior of parts of the environment we don't like. In other words, what's the real cause of earthquakes? Is it plates sliding past each other, the zipper effect that we've all been told for years and years and years?
That's what we've been told.
That's what we've been told. So why, the other day, I think you had Standeo on, okay, and he was talking about earthquakes at the South Pole?
Yep.
There aren't any plates at the South Pole, boys and girls. But there is a hyperdimensional hotspot, like there is on the North Pole of Saturn. On our website, if you go and you look at this paper, you will see a composite image that I've created.
There are no plates on the South Pole?
No.
Then how can they have earthquakes?
Exactly. You got your finger on it.
No, I don't. I heard what you said. That's all.
There's also activity at the South Pole. Mount Elbrus has been burping and doing interesting things, which is the major volcano down in the Antarctic. But there are no plates that are rifting apart the South Pole. If there were, Antarctica would not have remained a continent. All right, it would have sundered like the African rift. The Rift Valley is tearing Africa apart.
Well, now, wait a minute. This has got to be, then, a big challenge for geologists. I mean, what would they say? If you said to a geologist, there are no plates there, how can they have earthquakes? What would the geologist say?
Well, there are no plates on the East Coast, and there are no plates under the Madras Fault. Some of the worst earthquakes have occurred in the middle of continents. I mean, that's just historical data. the theory as to why you get terrible earthquakes along the Madrid Fault is kind of lagging. We've only had the theory of plate tectonics, Art, since the 1960s. Since the Glomar Challenger and the people at Lamont Doherty went around and dug, drilled cores around in the bottoms of most of the oceans, and came up with this idea. It's a theory, not fact. It's a theory. Now, it seems to explain quite a few things, but there are a lot of things about geophysics that the plate tectonic theory does not explain.
But they have, with lasers, for example, measured the movement of plates against each other.
I'm not saying the plates are not moving. I'm just saying that that's not the ultimate answer to all earthquakes and all geophysical activity.
Okay.
And what's going on at the South Pole right now is pretty interesting because the hyperdimensional model predicts that not only are you going to see a lot of activity, but that's probably the reason why you're getting a lot of melting. All right?
And by the way, there is a lot of... That's another story I'm following.
Yep.
They're talking about the possibility now, Richard, of the whole damn thing melting.
Yep.
And if that occurred, sea levels, they say, could rise by as much as 50 feet.
That's because of the bathtub effect.
Now, 50 feet. Do you know what would happen if sea levels rose 50 feet?
Why do you think I'm not in New York?
I guess you know what would occur.
Yes. In other words, if you take the ice and you plunk it down off the continent into the ocean.
Majority of our population lives right along that.
That's right.
Either one of the coasts.
That's right.
Yeah.
So major planetary changes that are kind of happening because of much bigger reasons than, burning coal are critical to figure out so we can do something. All right? Now, how do you do something?
That's my question.
You have to go to a type 1. You must control the energies on a planetary scale, and that means you have to think in terms of generators, in terms of grid points. Remember we keep talking about latitudes and longitudes in this dimensional model.
Yes.
Well, we have relics. We have ancient architecture scattered around this planet that our guys have now told us are basically tombs. Right?
The pyramids.
Pyramids. Maybe they weren't tombs. Maybe, as our physics predicts, they are huge hyperdimensional transducers sitting atop critical points on the global grid as an effort by a previous cycle of civilization to control this energy on a planetary scale and to keep Earth habitable for people living in certain regions.
If that is true, then it should be pointed out they ain't here anymore and we are.
Because maybe the problem was bigger than even they thought. In other words, there are escalating sets of problems. There's the short-term stuff of climate and weather and volcanoes. And the easiest way to get around volcanoes and earthquakes is not to live where they occur. All right? We know pretty well now where it's dangerous to live. And we know pretty well where, climate-wise, it's not good to try to maintain a civilization. But in terms of the biggest problem of all, let's hit it right on the head.
But wait a minute. Let's not leave what you just said.
Okay.
Don't live where these problems occur. Take the Ring of Fire, Richard.
That's right.
It runs all the way up South America. It runs right up the west coast of America, on up through Alaska, over to Japan, and on around. Now, you're talking about, I don't know, maybe 1/8 of the world's population, maybe more. So you can't just blow right by that. Don't live where the problem is. There's a lot of people.
The problem is that if you live where the problem is and it gets too severe, you're not going to be living. In other words, it is a self-correcting problem. It's like living on a river delta or living in an arroyo. You range in the mountains, you put your tent in the arroyo, you're not going to have a tent. If you're not careful, you're not going to have yourself.
Well, but I would imagine that your hyperdimensional physics model offers answers that don't require everybody moving away from these areas.
Provided the government, the structure we have established, promote the common defense,
yes,
turns its energies from killing people to defending us from the very physics that makes life possible. In other words, this requires a combination of foresight, vision, resources, and cooperation on a scale the human race is not known for.
But killing people is very important. We have a big budget for killing people.
Well, we could have a big budget for protecting people from being killed.
What a revolutionary idea.
Isn't that? We're up for some major changes, Art, whether we want them or not. And one of the things that I like about your show, even though I don't agree with everybody, including Ed Dames, what Ed Dames does is he gets people off their butt to think about the unthinkable. It goes to the core. It's basically an emotional, catch, but it gets people thinking that it's not going to go on the way it has.
Well, one thing about Ed Dames, whatever you believe, a lot of what he has predicted in the past is going on now.
Well, wouldn't it be interesting if Ed Dames' real source of information was a hyperdimensional model in some backroom computer at the NSA?
Could be.
And all he's doing is providing data that is acquired not by remote viewing but by science.
Well, Ed Dames could be black ops. I'm accused of it all the time. So he could be, he could be getting his information as you just described. Maybe that's where I'm getting it.
Well, the point is that I kind of agree with the Gestalt, which is to awaken people, to get them out of their lethargy, to look outside and see the sun shining and blue sky and say, oh, this is going to go on forever, because it's not. Now, you can be a doomsayer and say there's not a damn thing we can do about it. What's that great line, bend over, kiss your, goodbye?
That's right.
Or you can take the high road and say, okay, let's figure this out and let's see if there's something we can do that's intelligent.
I'd rather do that because I've got a bit of a belly now and I can't make that bend.
Well, that's my approach too. And remember, I didn't start out even beginning to think in this direction. I started out 15 years ago with a few colleagues looking at possible ruins on Mars. And where we wind up tonight is a physics which is predictive, which has stunning correlations. Things are coming true about this physics even as we speak, and I'm going to tell you about one now.
Okay, well, I think you're really on to something. Having said that, again, I press my question. If we had control of this physics and this energy, what could we possibly do to avert what otherwise will occur as a natural cycle?
All right, let me try to give you a couple of analogies, which people may or may not be familiar with, and I may have to give a little history here, so the grassy knoll folks are going to freak out. Remember the rage a few years ago about superconductivity?
Yes.
There was a physicist at the University of Texas named, I think his name was Chu, and he came up with a breakthrough following on a couple of guys at IBM in Zurich, a so-called room temperature superconductor.
I recall.
For the folks that may have forgotten, when you put current through an ordinary wire at room temperature, it basically dissipates heat because of resistance in the wire.
Correct.
Even a good wire, copper or silver.
That's correct.
All right. We use in our technology this effect to make light bulbs. All right. Thomas Edison found that certain materials were very resistant, and when you push current through them, they glow.
That's right.
You put them in a vacuum tube.
They produce heat as well.
They produce heat and light, and most of your light bulbs produce far more heat than they produce light. The efficiency is what?
If you doubt that, go touch your 100-watt light bulb after it's been on for about 10 minutes. And
many, many years ago, maybe 100 years ago, there was he wasn't Swedish, he was, I think, Norwegian, a guy named Kamerlik Owen, who was a physicist in Scandinavia, who discovered by cooling mercury, just the liquid metal mercury,
right,
that if he cooled it down low enough, suddenly it lost all resistance to electricity.
Right.
It became superconductive.
Right.
Now, the quest has been among engineers and technologists who thought this was a kind of a neat thing. Suppose you could make a material that would have this aspect
superconductive ability at room temperature.
At somewhere close to room temperature.
That's been the holy grail.
The holy grail of a lot of technology, because you can imagine that you could produce generators the size of, I'm going to be exaggerating here, thimbles, that would produce enough power for an entire city.
Well, you could produce certainly generators that would be far more efficient. Line losses in transmission lines would disappear. It would be a revolution, yes.
At all different levels. And in the 1980s, under the Reagan administration, when Dr. Chu at the University of Houston, I think, produced something kind of close to room temperature, you only had to cool it with liquid nitrogen.
Right.
Which is a lot cheaper than liquid helium, which they've had to cool previous superconductors, it looked like we'd have maglev trains and all kinds of other things.
Sure.
And they were announcing the Holy Grail had been achieved, the new millennium. Nothing ever happened, did it? There still is no...
No, it went quiet.
It went very quiet. Well, that's kind of that's a whole other show, all right? The point is that I got very intrigued as we got into the hyperdimensional model. Why does superconductivity exist at all? And it turns out, all right, it turns out that it's because of hyperdimensional physics.
All right. Now, in behalf of those in the grassy knoll, I'm going to stop you because we're at the top of the hour, so they win. Hold on, Richard. When we get back, I'm going to press Richard because I want to know if we developed this physics, and you can read about it. Richard has a paper that is worth the reading, and we want scientific feedback on it on his website, available through mine at www.artbell.com. If we could, then how would we apply it to changing what seems to be occurring? We'll see. Back now to Richard C. Hoagland. And Richard, I've got a fax I want to read, but first I want to re-ask my question one more time. If we have mastered the energy available to us by hyperdimensional physics, how could we apply it practically to change what appears to lie ahead?
Okay, let me go back to my analogy with superconductivity.
Yes.
The reason that light bulbs shine is because of resistance in the wire.
Gotcha.
The energy is going through the wire. It's being blocked.
Mm-hmm.
It's suffering collisions, resistance, and the energy of flow is being transformed into randomness energy of heat.
Right.
And light.
Right.
By direct analogy, and it's really more than a metaphor, it's actually at the core of the physics. The way you prevent earthquakes is to keep the energy from dissipating and make it coherent once again. So it flows through the earth without losses. So it doesn't dissipate and cause problems. Now that's a very large-scale explanation for a very complex subject, but that's in essence what you have to do. And one can start on the laboratory scale. One can scale up to, a county-size scale. Remember a few months ago the Russians were offering services to the Indonesians?
To create a cyclone.
To create cyclones?
Yep.
Tom Bearden, by the way, on our next appearance, I would like to appear with Tom Bearden,
okay,
who is acknowledged at the top of this paper. Tom Bearden is a U.S. Army physicist, retired, who's probably done more single-handedly to resurrect the real Maxwell equations and to point us in the right direction. And he has been claiming for years, Art, that the Russians really have a handle on this physics and have been using it primarily as a military weapon. Now, what's remarkable is that when they made that offer to, I believe it was the Indonesians, or was it Singapore? I forget exactly what southeastern country it was, southeastern Asian country. The only possible way that they could have offered that, to create a cyclone and to put out those fires,
right,
is if they have control of this hyperdimensional technology, which may be known to other people as Tesla technology.
Uh-huh.
Because the name Nikola Tesla must factor very heavily in the discussion of how do you convert from theory to a practical engineering to do important things.
All right. So this could slowly be built to literally a planetary scale.
It may not have to be slowly. This is where Frances Barwood comes back into the picture.
Yeah, let's talk about Frances. Very important. She's going to do a radio program, by the way, today.
That's right.
This morning on KFYI. She's going to be filling in for Barry Young.
Yes, in fact, the last time she did that, I was one of her guests.
Really?
Yes. Yes, it was a year ago.
Now, here's what I find to be really, really intriguing. She's in this race now in Arizona for... she's running to be...
Secretary of State.
And her opponent has gazillions of dollars. And she has almost no dollars.
Yep.
And she's actually... I'm hearing that she's ahead in the polls.
She is winning in the polls. because people are smart.
Incredible.
This is wondrously incredible, and it basically goes to my Jeffersonian streak, which is that most people, provided the right information, will make the right decision.
Well, this has not been the case in the past, though.
No, but remember, the physics is changing. And this physics, by the way, affects people. I don't want to digress here from Frances, but
right.
let's get back to its consciousness application down the line in the next few minutes. Let's take with Frances. The reason that I am really supporting Frances, up to and including the point of showing up at a fundraising dinner next Monday night, July 20th, Magic July 20th, in downtown Phoenix at the Tempe Mission Palms Hotel Resort. We are holding a fundraiser for the Barwood campaign, and I am one of the speakers. She's the other one. And we're going to provide a lot of new data, particularly in terms of the Phoenix lights and their relationship to the hyperdimensional model. Remember, Frances is being creamed in the local Phoenix press by the local Republican Party because she dared, like the kid in that Dickens novel, what was the Oliver Twist? You know, when the little kid said, "Can I have some more, sir?"
Yep.
And she stood up and said, "Can I have an explanation, sir? You know, what were these lights?"
Yeah.
And they have creamed her for daring to ask the unthinkable question.
I know.
Simply for asking the question of doing her job for her constituents and saying, what the hell flew over this city that was 2 miles wide and was seen by tens of thousands of people that you don't want to talk about? And everything in the kitchen sink has been thrown at an honest political representative who dared ask the unthinkable. And the neatest thing is that her opponent has $200,000. I think Frances Worcester at the last count was, $1,000, I think I heard tonight. And yet she is beating her opponent in every county that I have data now for in terms of polling in Arizona. Now, this is telling you something profound. It means that people are listening to radio. They're listening to your show. They're listening to the local radio shows there. They're listening to her positions. She has some very interesting positions on a wide range of issues. But her core issue is really our openness in government. It's basically, if you believe in the Constitution, if you believe in government of, by, and for people, at some point people have to count. And Frances Barwood is a lone voice saying people should count.
That's right.
And that's why on Monday night on the 20th at the Tempe Palms, I'm going to be showing up. It's one of these dinners where you actually, they charge you some money, and then a major percentage of that money goes to the candidate.
Sure.
And what I decided to do, because we had a major political win in terms of openness, you and I, on this show, with a lot of help from our friends listening tonight all across the country, demonstrated that if enough people demand, a la Jefferson, redress grievances from their government, even this government, something can happen, something magical. We got the pictures, Art, by demanding NASA give them to us.
It is true.
Cydonia.
It is true. We did.
And what I want to do is to go to Arizona, to Phoenix, and talk to a bunch of people in a room that are going to pay $85 a couple to have dinner with us and to see some remarkable data, including the STS-80 film, which we're going to show, to discuss...
Oh, you're going to show STS-80 there?
STS-80.
Really?
Yep.
You've been torturing us with that film now for about a year and a half.
Well, I'm kind of trying to be careful. And we showed it at the University of New Mexico a couple of weeks ago.
Blows people away. I mean, it really blows people away.
Well, Whitley Strieber gave you a very accurate report.
Oh, yes.
He was blown away. When he was here, when I took him to dinner...
Everybody is. I was, too.
I gave him a copy, and I said, go away and look at it. Well, he did. And he went on your show, and he kind of gushed.
I know.
The kind of thing to gush about. Now, coming back to Frances, the reason it's important that people turn out and support her at this dinner is, A, she needs money. She needs money for signs, she needs money for campaign stuff, the usual stuff.
Sure.
But more important is, if you want to see a reason why she should be elected, remember, the Secretary of State of the state of Arizona is a heartbeat away from the governorship.
Right.
And the history of Arizona politics is kind of interesting.
Oh, it's fascinating.
More governors
come and go.
Leaving unceremoniously.
I know.
And the Secretary of State sliding into the governorship. So in essence, this is really, guys and gals, an election for possibly the next governor of the state of Arizona. Now, can you imagine a person with Frances Barwood's integrity and mettle and strength of character and determination to serve being in a position of being governor of one of the 50 states and being able to say to the federal government, you open the files. You tell me why we're doing this and this and this, why you're flying over our seventh largest city in the United States, et cetera, et cetera.
I know.
And can you understand why the powers that be will do everything, including maybe move the damn planet to keep her from being elected?
I know.
And yet at the grassroots level, the message is getting through, her integrity is getting through, and I am not making this up. There was a poll recently, and this is how curious the politics are in Arizona. There was a poll recently conducted in most of the major counties, and the local media reported that the governor's, numbers and the treasurer numbers. They did not report the Secretary of State numbers. Mm-hmm. So Frances had to call a source that was privy to those numbers.
Yeah.
And we cannot reveal the source because that's how hatchet these politics are now. But it turned out that the reason they weren't reporting them is because against her opponent, who has $200,000 to her $1,000 tonight, Frances is winning.
Well, maybe I believe in miracles. I mean, if you look at the recent California elections, there's been a similar pattern, and the people with the money in California lost.
They go down like a streamlined anvil.
Yeah, and that's something really new.
It's really new because people are beginning to get it, that money does not translate to integrity or honesty or service or anything. Now, there's one more very important point. There are two data points coming up on this very tightly contested election. The next data point for Frances is the primary, which is September 8th, I believe. Okay, let me check my data here. We have 57 days to the primary. Arizona is a structured primary, meaning that only Republicans can vote for Republicans and only Democrats can vote for Democrats. Which means that if people want to see Frances elected, they have to get her on the ballot. They have to she has to win the primary against her Republican opponent. Mm-hmm. Which means that people need to turn out in droves and register Republican so they can vote her into the actual race on September 8th. Then if they want, they can switch back to whatever party that they actually want to belong to. But it's the way the game is played. And at some level, politics, unfortunately, has become a game.
Well, it's a small ray of hope. You remember the Who had a song called Won't Get Fooled Again. You remember that?
Yeah.
At the very end of the song, they said, new boss, same as the old boss. Well, Americans, I think, are starting to figure out that whichever boss from whichever party they elect, that's the way it turns out. New boss, same as the old boss.
Let me give out a phone number here in case people want to support us and show up at this dinner.
Okay.
This is Monday night, the 20th. Now remember, July 20th, we talked about on your show how important
very important date,
I
know.
Well, we picked this specifically just to kind of, give it to the you-know-who. So the number for tickets for the Barwood dinner is 602-704-1040. That's 602-704-1040.
Got it.
We have a lot of listeners all over the country. Even in New York, they're still listening.
Oh, yeah.
You could fly in. This would be a real show of support. And for folks who can't be there, if you just sent $1 to the Barwood campaign.
I know, she's like literally down to $1,000 of campaign money.
She's down to about $1,000. But if you just sent $1...
It's hardly gas money.
The reason this election is so important is because Frances is the only politician to have the guts to ask the unthinkable UFO question. Imagine if she makes it. Imagine the signal.
Well, Richard, there's a kind of a sea change going on in the whole UFO community. As you know, some major universities just announced they are going to study UFOs. They have said there now appears to be enough hard evidence to justify some major universities doing studies on UFOs. They don't conclude now that they're extraterrestrial in origin, but they say there is now enough evidence. So, so attitudes are changing.
But one of the things that I'm going to do, and I haven't even told Frances the details of this, is that we have developed some remarkable new political evidence of things that were occurring simultaneously at the other end of the country the night of the Phoenix Lights on March 13th, 1997. Mm-hmm. And for the first time, we're going to lay them out in terms of the national political scene and implications. This reaches, it turns out, all the way to Washington. So it will be a pretty interesting evening. If you show up and you pay the $85 for the dinner, you get dinner plus what we're going to talk about. If you only want to come for what we're going to talk about, that's only $50, all right? And about $25 of that ticket goes directly to Frances. We're trying to maximize the impact on her campaign. And for all those who can't be with us, if you just send $1, guys, you can make a tremendous difference because she is winning the battle.
Do you have an address?
For Frances?
Yeah.
All right, we have a linkage on our website, which is, you just go to our Enterprise Mission or to your website, Art Bell, and then click over to us. Her actual campaign, which is www.barwood.com, is linked on our site.
Okay.
I don't have, well, if I go through my paperwork
all right, well,
here,
maybe after the bottom of the hour.
After the bottom of the hour, I will find it. Okay?
All right. In the meantime, let me ask you about this. Art, as I'm sure both you and Richard know, the scientific method is observe, hypothesis, test. Richard's theory of hyperdimensional physics is an interesting hypothesis, but as of yet, it is only just that, a theory. Richard has always been a proponent of, quote, good science, end quote, and I'm sure he does not propose that the classical scientific method be abandoned. So the question is, how does Richard propose we test the theory of hyperdimensional physics so we, as scientists, can move forward with solid, reproducible scientific evidence for this new model?
Okay, I will get to that right after I give this address, all right? I have found the bar.
Oh, you found it, okay.
I found it, yes.
All right,
yes.
Go ahead.
All right, send your dollar to Frances Barwood, P.O. Box 86189. That's P.O. Box 86189, Phoenix, Arizona, 85080-6189. That's P.O. Box.
Whoa. Yeah, give that again. 850...
All right, let's start from the top. P.O. Box 86189.
Yep.
Phoenix, AZ. That's short for Arizona.
Thank you.
850-80-6189.
Okay.
And you can send more than $1, guys. In fact, you can send up to what? $720, I think, is allowed by state law.
Yeah, but even if that's all you sent was a buck
oh
or
my God!
something.
If just the people listening were to send $1, say this is for God, country, and honesty.
Yep.
The staggering impact on that election would be so profound, both psychologically and materially, that we would have a fascinating set of conversations in the weeks to come.
Well, we indeed may. I'm really looking forward to what would happen if she got elected. There'd be a lot of trouble in River City, and Benson would get real busy, and it'd be a fun time.
You know, the core thing that I am intrigued with Frances about, and I have been ever since we actually met, is that here is a politician who has vision. I mean, she expanded her envelope enormously by asking that unthinkable question. She would never imagine that UFOs would have anything to do with her lifestyle or politics or those of her neighbors or her, people she represented. And she did ask that question. And now that she's been fired at, big cannons brought out, governor making fun of her, the mayor talking to the tinfoil Frances, that kind of thing.
I know.
She's stuck to her guns. She's not shrunk from the hard questions on this. And people are getting the message, but not enough people in time to make the primary. So that's why she needs the help. That's why she needs people to convert to Republicans for the primary. And that's why I'm going there on the 20th to reveal some really remarkable things about those lights.
All right, good enough. When we get back, we will ask again about the scientific method and how we apply it to hyperdimensional physics to bring it from a theory to reality to practical application. This is Coast to Coast AM. All right, Richard, again, I thought this was a pretty good fax. The bottom line question was, how does Richard propose we test the theory of hyperdimensional physics so that we as scientists, this is one of them, can move forward with solid, reproducible scientific evidence for this new model?
It's an excellent question. Okay.
Oh.
I have composed a list of laboratory experiments going back now several years that are not very expensive, that we are going to, in the next several weeks, be carrying out. And we're going to, list the experiments and then list the results. And in the next week, I am taking a special trip to discuss with a potential, shall we say, collaborator, the laboratory setup for doing exactly what the FACSR proposes. That's on the laboratory scale. On the larger scale, one of the neatest things that really got me, into this whole thing was that we tripped over, Torrin and I tripped over, many years ago, 10 years ago now, in 88, 89, the astrophysical evidence that seemed to conform to the hyperdimensional model. And that was the locations on these planets all over the solar system, including the sun, of the largest energy production centers being located at this 19.5 degrees latitude that I keep talking about over and over and over again. That's not accidental. That's a convergence of physical forces that are currently unmodeled by any known physics, climatology, geology, whatever. And what we have done in the paper is we have listed very specifically some key tests that we're now urging NASA and other NASA-contracted astronomical facilities to carry out, pursuant to their announcement a couple weeks ago of this so-called new planet. Remember the announcement that came out the day after we did our hyperdimensional show last time?
Right.
Of Susan Turaby, this young astrophysicist in Pasadena, who set up her own corporation, the Extrasolar Research Corporation, and got a grant from NASA to basically look for planets around other stars. Well, she found, as part of her Hubble observing time, this funny little spark of light at the end of a long streak in a dust cloud of a double star system located about 450 light years away in Taurus, called, I think, TMC1, or Taurus Molecular Cloud Number 1.
Mm-hmm.
And what we've done in the paper is using Susan Turaby's discovery, lay out when they are giving her everything in the kitchen sink to verify her discovery in the next couple of months, beginning in August, all right? They're giving her more Hubble time, they're giving her time on Keck, they're giving her time on infrared telescopes. They're making everything available to Susan Turaby to verify that this is a planet. By the way, this is the same agency which has not taken any more pictures of Cydonia. Just want to put that on the record, okay? So one of the things we're proposing in the paper is that if Susan is looking at this object and trying to verify that it is a runaway planet, there are certain signatures in her data which will become apparent as she takes information from the various telescopes that will either support or refute the hyperdimensional model as applied to that kind of planetary system. And so we laid out those parameters in this paper, and they're on the website. We then extended this to astronomy observations that could be made by NASA and or their subcontractors of major objects in this solar system, particularly the giant outer planets, Saturn, Jupiter, Uranus, and Neptune. What is probably not well known by most people, but they can know it if they go to the web, is that those four outer planets, the big guys, are all glowing. Remember the old textbook astronomy definition of a planet art, that a planet shown by reflected light and stars shown by internal energy?
Yes.
Well, that definition has kind of lost its meaning, because beginning in the 1960s, astronomers were stunned to find that the outer planets are glowing. In the infrared, they are actually emitting more energy than they're getting from the sun, which kind of blurs the line between a star and a planet. And for the last 30 years, there's been a lot of discussions in the literature as to, well, what really makes them shine? Why are they glowing? And there are various explanations proposed, and we'll get into those tonight. The bottom line is that I've been able to take their luminosity, and there's a set of graphs in this paper, and I've been able to plot, like the old Big Bang redshift plots that Hubble did, 50 years ago, and demonstrate that for some exquisitely inexplicable reason, by any mainstream model, all the glowing planets, including, by the way, I put the Earth-Moon system on that graph, fall on a perfectly straight line. Their glow is only dependent on one parameter, one thing, their total angular momentum, which is basically spin energy, all right? That's the spin energy of the planet plus the spin energy of any moons going around the planet.
All right.
You total those up, you put it on a graph, X and Y axis, you get a beautiful straight line plot. In fact, the tightness of the plot is better by an order of magnitude or more than Hubble's original plot of galaxies that gave us the whole Big Bang model.
Wow.
At this early stage in this set of observations. So what I am predicting in the paper is, look, you want to test this model? The model says that the luminosity, if they're hyperdimensionally derived, will have one key difference with any other explanation that no one has yet tested. The luminosities should change with time. Both short-term changes, days, months, long-term changes, years. And because NASA and the guys that work for NASA believe that this stuff is cosmological, meaning it's kind of cast in concrete, it's on a huge geological time frame, once they got the luminosities pegged down from the Voyager and the Pioneer missions, they never went back and looked. No one has looked at the infrared signatures, the outputs of these planets, since the 1970s, because they think it's permanent. On a geological time scale, they're constant. Our model says, no, boys and girls, they're not constant. Go look at them next week, next month, next year, and they will have changed. Now, there's one mission.
Richard, these changes in luminosity, are these changes concurrent with the changes we were talking about earlier, volcanism, the weather changes, and all the rest of it? Is that what a planet goes through?
Yes. Short answer is yes.
Good.
And because you like short answers.
I like. So do people in the grassy knoll.
Okay. Look, there's a lot of correlating to be done here, and the neat thing is we have computers and the web, so we can all compare notes and do the correlating. And one of the things that I'm looking for are a few bright research assistants. I think I've got one pegged already, to help me now flesh out the model. There's really neat stuff to be determined here, and there's all kinds of mysteries that, if we're right, would be solved. I will give you one classic one, and it brings us back to what we discussed at the top of the show. Why are the Japanese interested in going to Mars?
By the way, somebody writes and wonders if you are not interested, perhaps, in defecting to Japan. No, okay.
No, because I can't speak the language. And as you know, I like speaking.
That's right. And it would take you years and years and years to learn to speak in the machine gun fashion in Japanese that you're able to do it here.
Precisely. Anyway, one of the key mysteries about Mars is, all right, think of this, all right? You've got a planet which is farther away from the sun than we are, right?
Right.
So it's colder.
Colder, yes.
Okay. It's obvious that Mars had rivers, had lots of water.
Oh, yes.
Had floods.
Oh, yes.
Okay. Now you got a problem. Because in order to have floods and rivers and all that, Mars had to be warmer than it is now.
Correct.
How do you get a warmer Mars if Mars has always been exactly as far from the sun as it is now? Which, for the sake of argument, we can definitely assume, okay?
Well, let me take a stab at it. That won't necessarily meet up with your hyperdimensional physics, but the warmth of a planet is to some degree determined by the density of its atmosphere.
Very good.
And that a lot of atmosphere that used to be there is not there anymore.
Very good.
So that's one possible answer.
Okay. Now, what you need to do is you put numbers to that, and when you do the numbers, and I'm not talking about our numbers, I'm talking about numbers in the literature, it doesn't really work. Sagan invoked what he called greenhouse gases, the same concept of Al Gore.
Yes.
There are natural greenhouse gases. They're primarily ammonia and methane. And in some of his early papers, Carl, in attempting to solve this really interesting puzzle, proposed that in the early billions of years of the solar system, there was a lot of methane and ammonia that was, mixed in with the other gases of Mars' much more luxuriant atmosphere, and those gases would trap sunlight and then be like a blanket and keep the planet warmer and allow for liquid water and rain and oceans and all that. Okay?
Here, yes.
There's only one problem. Other guys said, but Carl, those gases are very easily destroyed by ultraviolet, and they did calculations showing that the greenhouse gases would dissipate, be ripped apart within years, and so there'd be no more blanket and no more greenhouse. So, and there's another problem. The standard models of the sun claimed that in the early years, billion, 2 billion, 3 billion years ago, when Mars was younger and was supposed to have these rivers,
right,
the sun itself was 30% dimmer than it is today. So you got a compounded problem. You have a planet far from the sun, farther than the Earth, which would be even colder if the sun was 30% dimmer than it is now. Now, the elegant, exquisite solution to all this is that the current model for what makes the sun shine is wrong. It's not primarily thermonuclear fusion, it's hyperdimensional physics. And in that model, the sun was brighter then than it is now. Ergo, without greenhouse gas trapping, you could have rivers on Mars and a warmer Earth, and the paleontological evidence from Earth indicates that we have been getting cooler, and it used to be much warmer a long time ago on this planet, which all neatly fits with the theory and is part of the testing of the model.
All right. Richard, a lot of people are going to be reading your paper on your website, and they're going to want to respond to it. Now, you don't have email. For some indiscernible reason, you don't have email. And
because I don't have dummy on my forehead.
You don't seem to want email.
No. The simple problem is simple logistics, all right? I do not have the time to go through 300 to 500 emails per day. So what I'm trying to do is set up a filtering system. If people really want to reach me, there's a fax number on our website.
Mm-hmm.
All right? I answer the telephone more often than I probably should. So what I'm trying to do is to screen people who really want to care enough to not electronically dash off something, but put it on a piece of paper and fax it.
All right. Let us give out at least your fax number.
Okay.
All right.
505 771 0820.
All right. That at least gives somebody one way of responding to you.
Yep.
Okay.
Now, they can send, email to, we're actually going to change this very shortly because it has gotten to where we want technical input and people do rely on email. But I have not been able to handle the logistical problem of thousands of emails per week. I mean, we're not keeping up with what we're trying to do now because we do not have paid staff. I mean, this is a very small research political effort to try to change a very big problem.
Mm-hmm.
And we do not have the bucks to do that.
Okay. Very good. Look, I would like to begin taking calls.
Good idea.
If you wouldn't mind.
Absolutely.
You wouldn't mind?
More than wouldn't mind. Let's do it.
All right. Is there anything you want to sweep up before the top of the hour here?
How much time we got?
I don't know. About 4 minutes.
Okay. Tom, the essence of good science is predictions that turn out right. We have 2 of them on the boards tonight.
Well, the essence of good science is not necessarily predictions that turn out right. It's predictions. It's the scientific method applied to predictions to either prove or disprove them.
Well, but if your theory is wrong, you're only going to know it if
it's good. It's still good. It's still good science to prove a theory wrong.
All right, we're talking process versus results.
Yeah.
All right, I'm talking results. All right, you'd like to have your models prove out correct.
Sure.
I mean, no one likes to spend their time doing something that doesn't work.
Well, I was just pointing out that good science can also be proving something wrong.
Yes, we are not in disagreement. Okay, 2 points. Remember the Podkletnov experiment?
No.
Anti-gravity over spinning superconducting
Oh,
disk?
yes, of course, yes.
Of course, yes.
Thank you.
Well, hot new news tonight. I cannot tell you my source. It is not on NASA's official website yet, but according to an impeccable source that I talked to this afternoon, not only did NASA conduct the experiment 3 days ago, but they announced through a phone call to my source that it turned out to be positive. They are getting null gravity, less gravity, over the spinning superconducting disk at the Huntsville Marshall Space Flight Center experiment.
Oh, my.
That is predicted by standard theory.
Oh, my.
And it's exactly in line with the hyperdimensional model.
All right, now, give everybody a brief explanation of the experiment, which please, very brief.
Several months ago, there was a Finnish scientist named Podkletnov who announced that if he took a disk of superconducting material and spun it and put a test mass that was not electrically conductive above it, that the little mass would lose weight. 0.3%, I think, was the number that was quoted in his paper. All right?
Mm-hmm.
A lot of people were shooting at him. You know, there was a paper he was going to, put out new, and then he had to withdraw it, and there was a lot of acrimonious finger-pointing and stuff on the Internet and back and forth. NASA's people at Huntsville, at the Marshall Space Flight Center, quietly announced they were going to set up the experiment and see if he was right. It has now been over a year, and in December and January, they reported null results. Now they're reporting, quietly to my source, positive results. Now, we tried to call one of the co-experimenters tonight, and it was too late back east to get confirmation directly for airtime. But the interesting thing, of course, is that normally when you run an experiment, you shouldn't get a null and then a positive, unless you've done something really wrong.
That's right.
That's part of the problem with the cold fusion people. When Pons and Fleischmann first announced their remarkable experiments, people couldn't duplicate them. Well, the hallmark of the hyperdimensional model is that things you do today, you can't do next Thursday. But you can do them next Saturday, because it varies with time. It's cyclic, based on literal astronomical phasing, where the moon is, where the planets are, how the planet rotates, all that stuff. It's geometric. And the modulation being geometric, it's not going to be reproducible every single time by anybody, anywhere, at any latitude, unless you take that into the equation.
But if in fact we have reduced gravity,
yep,
then that is the first little baby step toward eventually possibly even eliminating gravity or going to a negative state in which one could turn the beat around, so to speak, and you would have a vehicle that would operate using gravity, virtually anti-gravity, yes?
Yeah, anti-gravity, and what my thinking is, and what we're going to talk about at the Barwood dinner, is that what the public NASA guys, the honest part of the system, are now beginning to duplicate is what the black projects have been doing very successfully for probably the last 10 or 20 years.
I can buy into that one. I think I had one of those things fly over my head. All right, we're going to pause here at the top of the hour, and when we come back, in those markets in which we come back, which are many, we are going to take calls. So if you have a question for Richard Hoagland, now is a good time to pick up the phone and begin to dial. You know the numbers. I'm Art Bell, and this is Coast to Coast AM. All right, you ready for some calls?
I'm ready.
Here it comes. Wildcard line, you're on the air with Richard Hoagland. Hi.
Hello.
Hi, where are you?
I'm Jeannie from Sunrise, Florida, and I listen to you on WFTL, which I guess stands for W Fort Lauderdale.
That would be it, all right.
Okay. Can I ask you before I ask Richard a question? I'm
Sure.
going to be moving to Knoxville, Tennessee, the end of January.
Right.
Where would I listen to you there? Do you know, or could you find out and announce it maybe one night?
Yeah, I'll start looking at the list while you ask Richard a question.
Okay.
Would that be TNN?
No, that would be not TNN.
Okay.
That's in Nashville.
Okay.
She said Knoxville.
Yeah, Knoxville, a little further east.
Anyway, go ahead, ma'am.
Okay. I would like to ask Richard, I intend to send $1 to Frances to help her, and like you said, if everybody would just do that, it wouldn't hurt anybody, and it would really help her. Could we do the same thing for you to help with whatever you're doing?
That's awfully nice. Actually, we checked with our attorneys, and yes, you may certainly do that.
Is there an address you could give us?
Yes, it's Enterprise Mission.
Enterprise Mission?
P.O. Box 1130, Placitas, Placitas, which in Spanish means Little Plaza, Placitas, New Mexico, 87043.
Okay. What's the name of the town again? It's
Placitas. Placitas.
Okay.
All right. If you're going to Knoxville, WNOX 990 on the dial, 10,000 watts in Knoxville, Tennessee will take care of you.
Okay, that's AM.
Yep.
990. Okay, great.
All right.
And I love your show, and
Thank you.
Keep it up.
All right, take care.
Thank you.
East of the Rockies, you're on the air with Richard Hoagland. Hi.
Yes, I was wondering...
I can barely hear you, sir. You're going to have to yell at us. Where are you?
I'm in Odessa.
That's better. Go ahead.
And I was wondering if earthquake scientists have taken into account the gravitational pull of surrounding planets in their estimates of when or when not an earthquake might come?
I don't think so.
No, Art. You are forgetting Jim Berkowitz.
Well, no, I'm not. I'm saying that the majority of them would not give any credence to other planets. They might talk about the moon. They might, but even that conventional scientists tend to balk at. So there are a few rebels like Berkowitz, but most of them, the answer would be no. You've got to admit, Richard.
Absolutely.
Yeah.
No, the effects we're talking about are not gravitational. They're hyperdimensional. Because in higher dimensions, which is what the hyper and hyperdimensional refers to, the planets, although in 3 dimensions are separated by, millions and billions of miles, in hyperdimensions, they're not separated. They are connected. So the forces and the interconnectivity and the effects all produce results in 3D that are not explainable by current theory, which is limited.
Okay, caller?
Certainly. I had one more question, if you don't mind.
I don't mind.
Yes. There's mention of an alignment of all the planets.
Right.
Within the year 2000?
I think it's May 5th of 2000.
Yes, I'm writing a fictional novel about the results of that. And I was wondering what your guest's opinion on...
Actually, it's rather a good question, yes. Richard, if you do think there is something to the gravitational effects of planets on each other, then what do you imagine might occur in a complete alignment of planets, if anything at all?
No. I did not say gravitational, except for the moon.
I'm sorry.
And Berkeley, the gravity effects are not.
A hyperdimensional effect.
Exactly.
Thank you.
All right. In the hyperdimensional model, where energy flows losslessly, like in a superconductor,
right,
is when the angles are 120 and 60. Where you got a problem is when the angles are 90 degrees and 180. The alignment in 2000 is when they're at 180. So the problem is that those inner planets, the ones we can see, that's the alignment that we're talking about,
right,
is 180. The outer guys, the ones we're proposing have to exist,
right,
are coming into, I believe, a 60-degree relationship, which means it's probably not a good day in Mudville. Because what happens is that the 180 or the 90s tend to make the energy dissipate. It's like you're driving along the freeway at 60 miles an hour, and suddenly a brick wall appears in front of you. What's going to happen? So I would say that it's a non-gravitational effect, but the result could be the same in that we need to kind of watch this one.
So no definitive forecast, but something is liable to occur.
Why have the Japanese launched 5 months early? What I was hinting at earlier in the show is if there are people in the black world, the secret world of this technology,
right,
which we see on the NASA shuttle flights and all that, who know this is not theory, they know it's fact, and they are taking their plans accordingly, then prudence would suggest that you get out of harm's way. If you cannot put in place a system to divert harm, you got 2 choices: either divert it or get out of the way.
Okay, very good. We'll have to wait and see, I guess. West of the Rockies, you're on the air with Richard C. Hoagland.
Yes, Richard.
Yes,
you mentioned that at 19.5 north and south of the equator is a special latitude.
Right.
Isn't there also such a special latitude north and south of the poles, 19.5?
No, it's reference to the equator because that's the way the geometry works, and there are higher order latitudes, like 30 degrees, 45, 60. It's curious that HAARP, which is this huge electromagnetic installation funded by the Air Force and the Naval Research Lab, is located north of Fairbanks, just about exactly at 60 north. and just about opposite the meridian of Giza, of the Great Pyramid. And the last show I did, I made mention that that was kind of coincidentally curious, because if you go back to Bearden's work, a la Tesla, you find that one of the ways to interact with the planet in a potential modification of these forces would be to use appropriate electromagnetic technology in ways that would attempt to interfere with the process which is changing the physics and causing the problem.
I see.
It's kind of like music theory, where
harmonics.
what you want is harmonics that are pleasing, and what we have currently are disharmonies. We have clashing notes. And the idea was massive electromagnetic technology, you could change the disharmonies into harmonies, which would in essence ameliorate the problem. But you need to do it on a big scale. And HAARP is the biggest thing going that kind of looks like that might be one of the things they're doing in secret and not telling us.
I see. What about, like, Hawaii? Why is that longitude so special? Why isn't there, like, Hawaii volcanoes all across the planet?
Excellent question. And we don't probably have time for a really detailed answer. It has to do with the ideal versus the real. When you used to study physics in high school, they'd give you these classic problems, Newton's first law, second law, third law. Then they would introduce you to a frictionless table with little hockey pucks sliding around on liquid CO2 to simulate a frictionless environment in weightlessness. Well, it kind of approached it, but it wasn't ideal. It was an approximation. The problem is that planets, real worlds, are not ideal. They're approximations. And so instead of having a ring of activity at 19.5, the activity tends to cluster at one point, at one longitude. And in our epoch, in our era, that longitude is under Hawaii. That's a kind of a simple explanation. It has to do with fluid physics in the real world.
Could the spin or this rate of the spin of the planet affect that hyperdimensional physics or energy?
The other way around. The physics changing is affecting the spin. And if you look in the paper on the web, there are two specific examples culled from the scientific literature that are really important evidence that we're on the right track. One is the change of dynamical time, meaning the spin of the Earth, relative to atomic time. Art advertises this atomic clock that resets itself and is accurate to 1 second in a million years.
Yep.
Well, we've added 20 seconds in the last 20 years.
That's true.
So that kind of throws that one into the ash can. There's something going on they're not telling us.
Well, it's still accurate. It just means they have corrected for whatever.
It's accurate, but it's out of step with the rotational clock, and they have to keep adding seconds to bring them back into step.
That's right. Mm-hmm.
Something is rotten in Denmark, actually, in Boulder. Number two, gravity is changing. What?
I was laughing.
Thank you. Gravity is changing. I mean, gravity is supposed to be a constant. By the way, this gets to the really exciting thing about what happened to the dinosaurs. If you look at dinosaur, skeletons.
Yes.
And you look at the size of these guys.
Right, they're big.
They're huge.
Yep.
No paleontologist now, worth his salt, has thought of the obvious problem, which is that you couldn't have Jurassic Park because the damn things would collapse under their own weight. There was a very brilliant engineer named Arthur Young who showed me a paper he had done many, many years ago. He was the inventor of the Bell helicopter, Art.
Right.
Before he turned to other things. And he was up in Berkeley, and I gave my first public presentation on the Mars data at his institute in Berkeley. Anyway, he gave me a little paper that he'd written, 20, 30 years ago, showing two curves parallel to each other. One, all the big guys that live on Earth now. Elephants, blue whales, big cats, lions, that kind of thing.
Right.
Rhinoceri. And then another line showing all the dinosaurs. And what he was able to form were two parallel curves showing that each large animal fit on a curve, but the two curves were not sequenced to each other. In other words, they were parallel, they were not contiguous, indicating to him that somehow gravity of the Earth itself had changed by a factor of a third between the time of Jurassic Park and now. Gravity has increased by a third since the time the dinosaurs lived and only the hyperdimensional model, A, predicts this, and B, explains how it happened, and it goes to the heart of Tom Van Flander's idea, which is a whole other show.
Right. All right. Wild card line, you're on the air with Richard C. Hoagland. Hi.
Hi, Art. Hi, Richard.
Hi there.
Yeah, hi, Art.
Yes, sir.
Hi, Richard. Sorry if I'm kind of talking not too loud here. I just want to say it's a pleasure to be on the air with both of you.
Sure. Where are you?
I'm calling from Chicago, Illinois here.
All right.
And I was wondering, Richard, this is a question for you. Is there anything to the isogonic value that changes with the Earth's magnetic north? Do you know what I'm talking about when I say the isogonic value?
No.
It's a variation that pilots use to correct for magnetic disturbance. You know, it's along the idea that true north is a magnetic north is not really at true north.
Right. The north magnetic pole is located somewhere around Hudson's Bay, as opposed to the actual inertial pole of the rotation of the Earth.
Right.
And it drifts, doesn't it, towards the west?
It's slowly drifting, yes.
Towards the west, is it, or is it like is there a direction that it is going towards?
It absolutely is, and I don't remember whether it's east or west, but I know that pilots need to do corrections for magnetic compasses based on reports given by the government as to how much the drift is.
I believe it's to the west. Those have been the majority of the reports we've had, and there are some pretty anomalous moves of magnetic north. I get faxes about it all the time.
Okay, again, this is wonderful work for correlations between those kind of things, polar wander, the so-called Chandler wobble of the Earth's axis. No one's doing this correlating because they don't think anything is connected. This model says all this stuff is really connected. We've got a meta theory now. We now need to put meat on the bones and do the tabulations and see if the correlations are there.
Right. And so how do we get mainstream science to do that?
Well, I've had nibbles from Los Alamos. That's one of the reasons that we're here in New Mexico, because we're in the center of what I call the Black Triangle. We have 3 of the most incredible research labs located within 30 miles of me, all right? Sandia, Phillips, and Los Alamos.
And you've really had nibbles, huh?
We've had nibbles since our university presentation.
Well, that's a beginning. All right, we're going to break here at the bottom of the hour. Richard C. Hoagland is here. If you have a question, we're going to lay into the phones as we have this half hour very heavily. I'm Art Bell, and of course, this is Coast to Coast AM. Well, okay, back we go now to Richard C. Hoagland in the beautiful mountains of New Mexico. Richard?
Yes, sir.
Here they come. First-time caller line, your turn with Richard Hoagland. You're on the air.
Good morning.
Good morning. Where are you?
I'm in North Dakota.
Okay.
Devil's Lake, North Dakota. We're experiencing flooding here.
Yes, sir.
As a good part of the country is right now. And I was wondering if it could be from the warming of the Earth from the inside. I know so much oil has been taken out, and oil is a heat barrier. Is that possible that we're being warmed from the inside out?
Not really. The main thing that's going on is on the surface in terms of weather. And what drives the weather cycle on the Earth is the evaporation and then condensation of the predominant component of the Earth's surface, which is water. I mean, they don't call this the water planet for nothing. And 3/4 of the surface is covered by oceans. And that water, when it gets into the atmosphere, when it's evaporated, has to condense somewhere eventually. Mm-hmm. And I'm calling this whole thing now hyperdimensional weather because it's so capricious and funny weird things are happening. Like Dames predicted years ago, the jet stream would come down to the deck.
Yep.
Well, what you're doing is taking a current of air, which is flowing along at 150, 200 miles an hour, and then you're putting a kink in it. And so that 200 mile an hour jet stream of air suddenly touches the ground, which it never is supposed to. Well, it's those capricious things that the hyperdimensional model says have to happen, because energy is building and energy has to go somewhere. If energy is building, it's going to evaporate more water. That water eventually has to condense. somewhere. So the change of local weather and the change of large regional climate is, in essence, predicted by the changes in the fundamental drivers that behind the whole system, which is more energy in the system.
So could you use this as a map predicting all types of global changes?
Well, in the best of all possible worlds, yes. The problem is that even with conventional physics and good old thermodynamics, the computer models, I mean, just look at your local weather forecast. How accurate, how far out are they? These are infernally complex equations to solve.
But I like you, believe that everything goes in cycles. And
that's right, but we don't have enough data, good data, because our lifespan, the lifespan of science, I mean, Art said a few minutes ago that according to the British, this is the hottest summer on record. Well, we only had records going back, 100 years maybe?
Yeah.
200 years? We're talking about changes on the order of thousands of years, if not 13,000 years for the half cycle that I've been gently referring to.
Right.
So we really have no hard data. Now, we have softer data. We have things like varves in lakes. We have flood strata levels of, like, the Nile. We have, estuaries around, let's say, the big lakes in the southern part of the Soviet Union. We have gross climatological features. We have isotopic measurements in ice cores, but let me give you a caveat. If we're right, if this physics really is a physics, then all of the radioactive measurements and all of the climate data based on radioactive measurements like isotope changes is immediately suspect.
Mm-hmm.
And let me tell you why. A few months ago, there was a demonstration on Good Morning America. This is referenced in the Hyperdimensional paper. And on live television, as part of a cold fusion experiment witnessed by Michael Gillian, the experimenters stuck an isotope of uranium, U-235, I believe, in the middle of the cold fusion device. U-235 has a half-life, meaning it takes X number of years for half the radioactivity to go away. That half-life is 4.5 billion years. They were able, with this machine, in time-lapse photography, to demonstrate that in about an hour and a half, they got half the U-235 to go away.
I saw that.
This is
I saw it myself.
incredible.
Yeah,
This is astonishing. This is impossible. This is hyperdimensional physics, which means that every single measurement of Earth climate going back 20 years, 50 years, 1,000 years, 10,000, 50,000, 200,000, based on radioactive measurements or isotopes, or even things like dating, like carbon-14 dating of archaeological stuff, has to be totally rethought because radioactivity is not a constant in this physics.
That could throw everything off.
It sure could.
Well, thank you very much, guys.
Kohler, thank you. Well observed, Richard. It certainly could throw a kink into carbon dating. Boy, oh boy, oh boy.
Well,
that'll make a lot of people happy, by the way.
Well, it simply means, Art, that we should be a little humble. This science today is a process. It's a journey. It's not an end. We haven't arrived. And the sooner that we get off our pedestal and think that we know everything, the sooner we start saving people's lives, property, their future, their children's future. In other words, the sooner we start acting like adults instead of kids having tantrums saying...
Well, there's not a lot of humble, Richard, in science. There's more ego than humble.
But there has to be humble, and that's why we come back to Frances Barwood. The way we redress this is through a political process. Remember, the science that is being funded today, by and large, is being funded by all of us with our taxes. If we demand a certain standard, then we'll get it, but we got to demand it. And the only way to do that is through an intelligent political process with people of integrity.
I agree. Wildcard line, you're on the air with Richard Hoagland. Hi.
Well, good evening or good morning, wherever you want to say it.
Mostly morning.
All righty. My name's Roy. I'm up here in Fallon right now. I'm a truck driver.
Yes, sir.
And Richard,
yes, sir.
Good morning. When I was up there, I used to run flatbed quite a lot up north. And I ran up over into the Pasco, Kennewick area of Washington. and I ran in a compression chamber door that I'd picked up in California. I took this up to a laser technology station up there that was 3 miles square. That's 3 miles 4 different ways. And they said that they were setting one up there, one up over in Europe, one over in Japan, and these were all laser beams that was going to check the gravitational pull from the planets and shifts in planets and stuff like that, and see if it done anything on Earth. And if all of these matched at the same time, it showed gravitational pull. Are you aware of this?
I'm aware of it in theory. I didn't know exactly where the stations were or where we are with that.
Well, I thought they were blowing smoke up my you-know-what, because I've seen some interesting stuff as a truck driver in 10 years. But, I mean, I've got to tell you, Art, this was amazing. And the stuff they were telling me was far beyond my comprehension. It was just something that I wasn't sure if it was true, if they were blowing smoke up me or what, but I'll tell you what, this was amazing. And they had these compression chambers, because I guess they have to fill them all with these different kinds of gases. And they were saying that these gases is what shows if it goes off a line so much of 1,000 millimeter seconds or whatever. Like I says, I don't know the dynamics of it. But these chambers themselves were a heck taller than a 2-story house, and probably as wide as 2 semis wrapped around each other. I mean, these were huge. And they were all built, they had concrete tunnels built above ground, all the way around, and every mile they had themselves what they call a pilot station. And on the very corners, they had these huge buildings set up on each corner.
Which had prisms in them, I presume.
I never got to go into these main corners. I delivered a compression chamber to one of the mile center buildings.
God, I wonder what that could be.
Call them.
Okay, well, it sounds like an interferometer, or a version of a ring gyro laser, where you send the beam around both directions and measure the clock times.
Right.
You know, and then you measure the phase shift. And yes, depending upon various atomic constants not being constant, you will get changes in the laser output at the end of the experiment. In other words, what we have is an in-crowd and an out-crowd. We have most physicists and most people thinking we have a certain science. Then we have other guys that somehow are part of the black world that know a lot more than the honest guys do, and there's no communication between the two, except randomly and occasionally when an honest guy will stumble across something.
Sure.
And then he is either, you made an offer he can't refuse to come in from the cold, or he's turned into an idiot and made to seem like a laughing stock because he knows things he shouldn't know and he's not part of the in-crowd. That's why we go back to Francis. Unless we have representative government that can bring these two worlds together, we're not going to be very happy on this planet very much longer.
All right. East of the Rockies, you're on the air with Richard C. Hoagland. Hi.
Yes. Good morning, Art.
Good morning.
Good morning, Richard.
Good morning.
My name is Carl, and I met with you in Phoenix last year at your meetings there in Phoenix.
Where are you, Carl, now?
I'm in Atoka, Oklahoma.
Okay.
Perhaps you remember I tried to speak with you several times there, and we never got a chance to really get into some of the deeper things that I wish to cover with you.
Okay, if you say so. It was a very crowded night. 2,000 folks showed up.
Yeah. I just sent a letter to Miss Barwood and asked her to forward a copy of it to you.
Okay.
It has to do with part of the extinction cycle of events that's coming. Part of the desynchronization of the moon's orbital gravity.
Oh, I remember. Yes, we did have a brief conversation. I remember very carefully that you had some pretty interesting stuff.
Yes. The problem that we face, Richard, is we are out of time, and if we rely on the politicians and the status quo, they're not going to do what has to be done in time enough to do it. So we literally face the total extinction of all the life on the Earth.
Well, all right, that's the ultimate negative. Let me try to ameliorate that just a bit, okay?
Okay.
If things were going on the way they are, I would agree with you. But what's going to happen, and this is going to be my one and last prediction tonight, Art?
All right.
We're going to see a couple of very interesting major events. And a lot of people are going to, unfortunately, get hurt. Those events are then going to sensitize a lot of other people that, oh my God, it's not linear. Things are happening that we can't control. And that means that the bulk of the mainstream will begin to pay attention to where they're not even on the paper at the moment, all right? At that point, the neat thing is, this is the important thing everybody should take away from this conversation this evening. Nothing I'm discussing has to be invented. It already exists. It exists in the black world of national security, of physics, of the Cold War, of the development of extraordinary toys. You know that old joke about what's the difference between boys and men? It's just the expense of their toys.
That's right.
All these toys exist. They only have not been applied to the bigger problems because the guys with the toys don't know that they're applicable to the planet. They've thought of them as gadgets, as war toys, as, you know, part of the Cold War. They haven't thought yet on a scale big enough. But the fact is that when the mainstream demands answers, the answers are waiting in the black community, and it requires honest political brokers like Barwood to get at those answers quicker than we normally are going to be able to get to them.
Makes sense, caller?
Yeah, you know, I spent 6.5 years in prison, held illegally without due process of law in this United States of America because of some things that I discovered in 1988. I tried to have something done about that through the government and the FBI and CIA and Secret Service and some other people that I had dealt with when I was in the service.
Why were you in jail?
It has to do with the killing of a guy that ran a CIA operation in Palo Alto, California.
Were you accused of killing this guy?
No, not at all. In fact, I warned him that he was down for being bumped off, and he didn't listen, and he is no longer with us.
So then why were you put in jail?
Due to things that were not done when I asked for an investigation.
No. People are put in jail when they are convicted of a specific crime. What were you convicted of?
I set up a sting so that they would pick me up so that I could have my day in court.
Let me repeat the question one more time. What were you convicted of?
Pardon me?
What were you convicted of?
It was not a conviction, but I was thrown in for a machine gun that did not fire.
You were thrown in for a machine
gun that would not fire a round.
No. There are laws regarding the possession of machine guns. I don't know about whether it wouldn't fire or not, but I guess I've gone as far with that as I can. West of the Rockies, you're on the air with Richard C. Hoagland. Hi.
Hi, Art. Hi, Richard. How are you all doing tonight?
Just fine.
My name's Richard also. I'm calling from Humboldt County, California.
Yes, sir.
Richard, I'd like to ask, well, before I get into that, Art, I just want to ask you, what do you think the jump in circulation was for this month's issue of Penthouse? Because I know I don't usually buy it, but I thought they treated you well.
I thought it was a very good article, and...
I heard I was even mentioned.
Yeah, they
you were, as a matter of fact. That's right. I don't know. I'm more interested in the demographics. In other words, you wouldn't normally presume that, say, a lot of old ladies would go and buy Penthouse, right?
True.
So when they get all the figures together after the month, it'll be interesting to see the demographics of their sales.
Uh-huh. Yes, I agree. All right, well, let's shift gears for a second here. Richard, I'd like to ask you, what do we know about the Phoenix Lights, on March 13th and subsequent nights? And also, there was a UPN show I'm sure everybody's pretty familiar with, where they put forth some kind of a hologram theory. Do you know what I'm talking about?
Hologram.
Total baloney, okay?
Yep. All right. But his first question, we don't have a lot of time, Richard.
Yep.
We are down line from the Phoenix Lights a long way now. What do we know?
Well, we know that something physical appeared to tens of thousands of people. Linda's had a lot of interviews. I've talked at great length with Delatoso and Mike Tanner and other folks. We know they were not flares, all right? We now have an astronomer who was the former he was kind of my equivalent at CNN, who went to Phoenix, conducted his own investigation, and has come to an independent conclusion of any of us that, in fact, there was something real physical in the skies over Phoenix. And it was obviously operating on some kind of physics that is not currently known. Now, was it ours or was it theirs? There is evidence in both directions. And one of the things I'm going to present at the dinner on Monday night the 20th is evidence that Washington was in the loop, and there was a lot of phone calls and a lot of reaction to whatever took place over Phoenix. We have had a number of people over the years, Art, breaking cover and kind of revealing things that they probably shouldn't.
Right.
One of the models is that this is ours. And some guys decided, because this physics is so critical to our long-term well-being, to make a demonstration so that it would be undeniable that somebody has control of this technology and that it should be brought out in the openness, and that people like Barwood would be, very effective in bringing it out.
So you theorize it may have been some kind of demonstration. All right, listen, we're out of time. The appearance in Phoenix on the 20th, is there a phone number?
There sure is.
What is it?
On tickets, it's 602-704-1040. 602-704-1040 for the Barwood fundraising dinner.
All right, my friend. As usual, it's not really goodbye, but until next time.
Or, as they say in Paris, au revoir.
Yeah, they do say that. Richard, thank you.
Thanks, Art.
Good night, my friend. All right, that's Richard C. Hoagland, folks, and we will be back tomorrow evening. Got a very interesting show planned for you on Soviet defectors. You're not going to want to miss it. From the high desert, good night.
Many divorced fathers.
Is Dr. Michio Kaku. Dr. Kaku, welcome.
Glad to be on, Art.
Great to hear your voice again. All right. Where to begin? I read a story the other day that I want to ask you about straight out of the chute here. It was, and I don't have it in front of me, but basically it said there was a tabletop experiment recently, virtually could be done on a coffee table, in which nail polish remover or acetone or something like that was bombarded with some sort of a sound, a cavitation, something or another. Anyway, little bubbles formed of energy which indicated to the experimenters that there was some sort of reaction going on, some sort of a chain reaction or production of energy. Have you heard about this, and what is it?
Yes, this is creating quite a bit of a stir in the physics world. The result was done at the Oak Ridge National Laboratory in Tennessee, where the uranium for the atomic bomb was processed. And this effect is called sonoluminescence, that is the creation of light from bubbles. Okay? Now, this effect was first noticed by the Nazis during World War II. They were trying to perfect submarine blades that could go into the oceans to knock out Allied ships. And they noticed that as the blades were spinning, bubbles began to form, and when these bubbles collapsed very uniformly and evenly, and when they collapsed, they created temperatures comparable to the surface of the sun. Now, this is rather incredible. Bubbles collapsed and creating temperatures of about 10,000 degrees Fahrenheit, comparable to the surface of the sun, which was sufficient to make these bubbles glow. Now, the Nazi scientists thought this was an odd effect. That is, submarine blades create bubbles that could sparkle when you looked at them.
Right.
But it was considered an anomaly. Okay? And, of course, then World War II took place, and people forgot about this.
You can still see it. I mean, I've been on a number of cruises, and you go to the back of the cruise ship at night, and you can look down and see the glow from the cavitation.
Well, this is an effect that is rather easy to produce, okay? Now, the key is, if these bubbles were to collapse extremely uniformly, and that's the key.
Yes.
If they collapse very uniformly, then temperatures skyrocket as a consequence. And temperatures of perhaps hundreds of thousands of degrees can actually be attained in the laboratory. Now, here's the catch, and this is what's creating a lot of controversy. If you can hit temperatures of about 10 million degrees, then at that temperature, you can get hydrogen to fuse. That is, the hydrogen nuclei combine to create helium with extra neutrons.
Right.
That's what takes place in the center of the sun, not just on the surface of the sun, but in the center of the sun.
Uh-huh.
And that's fusion. So in other words, anyone who can create fusion on a tabletop could in fact create a second industrial revolution. Now, this, of course, has to be verified in other laboratories, and it has to be watched very carefully. There are already some naysayers who say that perhaps there was contamination involved. But this group at the Oak Ridge National Laboratory claims that neutrons, which are, of course, nuclear radiation, neutrons were coming out of acetone.
Yeah, they measured it, right? They measured the radiation.
Yeah, they measured the neutron radiation coming out, and neutrons are the telltale signal that a nuclear reaction, not a chemical reaction, but a nuclear reaction is taking place. Now, of course, chemists and physicists were burned once back in the 1990s when Pons and Fleischmann announced that they had fusion in a glass of water.
Well, they're over in Europe still working on that.
Yeah, and maybe they did, maybe they didn't. But the question is, it has to be reproducible on demand. If you have a Toyota or a Chevy and you turn on the ignition switch, you want to make damn sure that engine turns on with your cold fusion device inside your engine.
That's right.
So far, it's iffy. Sometimes it seems to work, sometimes it doesn't work, and it's not reliable, and there's a lot of controversy about it. However, here, there's no doubt that sonoluminescence can attain a few 100,000 degrees. There's no doubt about that. That's been done in the laboratory, far beyond what the Nazis envisioned during World War II. The question is, can you attain perhaps 10 to 100 times that, or perhaps 10 million degrees, at which point hydrogen will then turn to fusion, and that's what makes the sun shine by E equals mc squared.
Well, how likely, or how promising, I guess I should ask, do you consider this experiment to be? How promising?
Well, very promising. However, it has to be verified. There are some naysayers who say that contamination from outside neutron sources may have created the burst of neutrons from this glass of water, basically, this glass of acetone. However, and this is a big if it turns out that this glass of acetone actually did compress bubbles up to 10 million degrees Fahrenheit, then this would be the world's first. That is, cold fusion would then take place in a small glass of acetone, or nail polish remover, as you said.
Why, as a matter of curiosity, any idea why acetone versus anything else?
It could be almost anything. You want a pure liquid, a liquid that's extremely pure in composition, that has lots of hydrogen molecules. Okay. And acetone has lots. It's a organic chemical, so it has lots of hydrogen molecules in it, and that's what you want. It didn't have to be that. It could have been, dry cleaning fluid. That's also rich in hydrogen molecules.
What does it mean if it works?
If it works, and you can make this on a large scale, and there are a lot of ifs involved, okay, then it means a second industrial revolution where energy comes from small little glasses of water or acetone or hydrogen-rich materials. Now, the oceans of the Earth are full of hydrogen. Therefore, in some sense, seawater could be used to drive a lot of these things to create fusion reactors, which would be safer. They would be still radioactive, but they would be relatively safer than fission reactors that we have at the present time. And, of course, we are slowly running out of oil. And the other option is nuclear, but, nuclear has a lot of safety problems. And so some people think that perhaps cold fusion is the way to go if this result can be verified in laboratories. It would be an inexhaustible source of energy. Fusion depends on seawater, and we have plenty of seawater in the oceans. And its waste product would only be helium gas. I mean, think about that. A waste product would be an inert gas that's non-polluting, okay? And it's almost too good to be true. And just remember that this is the energy source of the universe. This is what the universe uses for its energy. Stars burn very cleanly. Hydrogen is converted to helium. Helium is a waste product, but it's a very benign waste product. And helium will also fuse in a red giant.
All right, just for the sake of this discussion, let us assume that all of this turns out to be true. How big a step for humanity would that be toward becoming a Type 1 civilization?
Well, this would be an enormous big step with a lot of ifs that have to be satisfied, of course. We're talking about inexhaustible sources of energy almost for free. This would be comparable to the unleashing of steam power about 150 years ago. Steam power, of course, was the energy source that energized the Industrial Revolution and took the feudal societies of ancient Europe into the locomotive age. And it was the locomotive, of course, that helped to colonize the United States within just 100 years, a twinkling of an eye. And so it was steam power that revolutionized the last century. And so we're talking about a new leap on that scale if these results pan out.
Well, that's interesting because it has always seemed like a race to me between self-destruction on the one hand and attaining Type 1 status on the other hand, as you have so always clearly pointed out. Maybe we ought to go over it for the audience again, what the different types of civilizations are, and we will, but it's been a race. Do we self-destruct, or do we make it to Type 1? And I think it's still too close to call, don't you?
That's right. You see, any society in outer space coming out of the swamp, rising to attain modern status, would inevitably discover element 92, uranium. It's inevitable. They would discover hydrogen, helium, lithium, and eventually they hit the number 92, uranium. And also, they discover plastics and hydrocarbon chemistry and pollution. So it's inevitable that they will face two very important milestones. One is the ability to blow themselves apart, and the other is the ability to poison themselves to death. Okay, this is inevitable in outer space. So the transition from a Type 0 economy, which is based on basically oil and coal, that is, dead plants, a Type 0 civilization may never make it to a Type 1 civilization, which is truly planetary, a planetary society, a society based totally on planetary energy, capable, for example, of controlling earthquakes, of controlling the weather, of having cities on the ocean, totally in command of anything planetary. We may not make it because we have those two very destructive aspects of the industrial age, that is, nuclear weapons and pollution. And in outer space, perhaps that's one of the reasons why Type 0 civilizations never make it to Type 1. And perhaps that's why our radio telescopes don't pick up signals.
Dead planets.
They're probably the dead planets. When we go into outer space in the future and visit some of these planets, we may find radioactive atmospheres.
When the Berlin Wall came down and the Soviet Union collapsed, we all went hooray, and they moved the Doomsday Clock back many minutes, and we thought it was all over. Well, just the other day, the Bulletin of Atomic Scientists moved the clock forward an unprecedented 2 minutes in reaction to the 9/11 affair, what's going on in the Middle East, the war in Afghanistan, and the whole mess. So in this race right now, it seems like we've just taken about 2 steps to the rear.
That's right. We're talking about the proliferation of nuclear weapons and nuclear materials. Nuclear materials are proliferating every which way. A lot of it from the former Soviet Union. There are, for example, 4.4 pounds of highly enriched uranium that are missing from the Russian stockpile. And no matter how many times we ask the Russians to account for all their enriched uranium, there's 4 pounds of unaccounted for enriched uranium that's missing.
4 pounds. 4 pounds.
Yeah, now, that's not enough for an atomic bomb yet. To get an atomic bomb, you have to get 10 to 20 pounds of highly enriched uranium. But it's not comforting knowing that weapons-grade materials now, not just ordinary reactor-grade or hospital-grade, but highly enriched uranium, some of it is unaccounted for in Russia.
There are even those who say there are actual bombs unaccounted for.
Well, I live in New York City, not that far from the World Trade Center.
Right.
And there was that blip in the news last month. Time magazine reported the fact that perhaps a 10-kiloton nuclear weapon could be smuggled into New York City, the same way that heroin comes into New York City. And that would really ruin my day if a 10-kiloton nuclear bomb were to blow up in New York Harbor.
Hundreds of thousands, ultimately, of deaths, correct?
Perhaps millions of deaths. There are about 8 million people just in the New York City metropolitan area.
Some would die very slowly of poisoning, right?
That's right. Instantly, perhaps hundreds of thousands would perish if a bomb of that size.
But ultimately, millions with the poisoning.
That's right.
Doctor, hold on. We're at the bottom of the hour. Dr. Michio Kaku is my guest. Well, I made a sort of a slip there, and I said nuclear physicist. Certainly is not that. But you were given the opportunity to be that, weren't you?
That's right. When I was about to initiate my doctoral work, Edward Teller, the father of the hydrogen bomb, who was sort of a mentor of mine in high school, and when I was at Harvard, made a very strong push for me to go to the Livermore National Laboratories or the Los Alamos Laboratories. And he pretty much offered me a fellowship to study at Livermore.
How did you come to turn that down?
Well, I began to realize that, science is a double-edged sword. It's very powerful. One edge of the sword can create weapons of mass destruction. The other side of the sword can reduce poverty and cure disease and create a material abundance for all of humanity.
Surely, though, Dr. Teller must have made some kind of moral argument to you to try and convince you.
Well, you see, I'm a physicist, and we physicists are challenged by puzzles. And a hydrogen bomb, believe it or not, is built like a watch. And the explosion takes place in stages, microsecond by microsecond.
Right.
And he was sort of appealing to me as an intellectual challenge to the whole process of creating nuclear weapons, and an intellectual puzzle, a challenge to create the largest bang per buck, basically. And I personally was more interested in the biggest bang of all, that is the Big Bang, the creation of the universe.
Yes.
But he made a very strong push for me to go to perhaps MIT or mainly the Livermore National Laboratory or Los Alamos. But I decided eventually that this was not my cup of tea, that I would rather, carry on the tradition set forth by Einstein many decades ago.
That must have been some hard decision for you at the time.
A lot of hard decisions, because the scholarship that I was on at Harvard was the Earth Engineering Scholarship, which is the Star Wars Scholarship, as the New York Times has now dubbed it. And it was the scholarship that propelled a whole generation of physicists like myself into Livermore and into Los Alamos to design the Star Wars program. So my whole career, basically, up to that point, was basically funded by other physicists who wanted me and people like me to join the weapons laboratories.
All right. Tonight, I had asked you, I've been hearing all these stories about quantum entanglement, and you wrote back that quantum entanglement is not at all an easy concept to explain to the public. Some aspects you say are quite difficult and mind-blowing. But I'd love to make a try. Maybe we ought to start down and just discuss, when you say quantum, what does that mean?
Well, quantum is an overused word. You have quantum securities, quantum healing. Everything is quantum these days. It's a very sexy word. Quantum Leap is a TV program. But quantum physics is basically atomic physics. And in the atomic world, the world of photons or particles of light and electrons, we have rather bizarre properties that defy common sense. Electrons that can be apparently more than one place at the same time. Objects that spring into existence when you observe them. It's a very bizarre world at the atomic level. However, the quantum theory is perhaps the most successful theory ever proposed by the human mind. It's been shown to be accurate to 1 part in about 10 billion, which makes it the most accurate theory ever proposed. And electronics, laser beams, computers, all the electronic marvels that we have in our living room, all of them are made possible by the quantum theory, by electrons that dance between orbitals and are in two places at the same time.
All right.
Objects that don't exist till you look at them.
Okay.
Bizarre properties that defy common sense, are commonplace at the atomic level.
All right. Then, if that is the case, what is the term quantum entanglement imply?
Okay, quantum entanglement could be the key to what is called quantum teleportation. Now, in 1993, at IBM Laboratories, scientists there made a thought experiment about what it would take to transport, like in Star Trek, by the way, an object from point A to point B using quantum physics.
Okay.
And they came up with the world's first realistic scenario for what a transporter may look like, even though, of course, it may take centuries to actually build one of these damn things. But in principle, it seems to work. And a few years ago, it was actually proven to work. We can now transport individual photons or particles of light, okay, using this method.
That's what I've heard, yes.
And in the next decade, we hope to transport the first molecule, perhaps a buckyball, you know, one of these carbon atoms that look like a soccer ball.
Yes.
And perhaps beyond that, the first virus. Okay, so this is sort of the game plan.
A virus, huh?
Yeah.
Figures.
In maybe 10 years, a rather complicated molecule like a buckyball, and perhaps maybe in 20 years, a virus. Now, quantum entanglement means that the universe is not local. When we think that if we touch something here in our room, this means that the effect is only apparent in our room.
Right.
Okay? We don't think that when we touch something here that in a neighboring star, something else occurs in a neighboring star. That would make the world non-local.
You mean action-reaction?
Yes. So,
or action-action, which...
Right. So if something here on Earth could immediately affect something on Alpha Centauri, which is 4 light years away, right?
Yes.
That's considered impossible. That means that things could travel faster than the speed of light, for example. Now, unfortunately, the world is non-local. And this is called entanglement. That something here on Earth could be entangled with something in Alpha Centauri, so that if you make a measurement here on the planet Earth, it immediately affects something in Alpha Centauri faster than the speed of light.
Or here on Earth as well, somewhere else here on Earth.
Or even here on Earth, 2 places on Earth.
There's a whole non-local argument. Now, let me ask you this. I have interviewed, our own government had this remote viewing program going on for 20 years, at taxpayer expense. They had remote viewers trying to visualize gas canisters in Iraq and all those sorts of things. And there was some success with it, some level of success, despite what has been said about it. There was success. And the remote viewers claim that their information comes from this non-local everything. That everything is connected and that their information flows from this, what would you call it? This non-locality.
Right. Okay, well, let me try to explain non-locality. First of all, Einstein himself didn't like it, and Einstein proposed an experiment to try to prove that the universe was not non-local, but apparently it is. The universe really is non-local, and Einstein was wrong on this one. And this experiment has been done quite a few times in the last decade. Okay, it was first done in 1963, I think. Here's what you do. You get a beam of light, like a laser beam,
right?
And you split it using a piece of glass. A piece of glass will bend the beam to the left and to the right simultaneously. Part of it will reflect, and part of it will go right through. Okay?
Mm-hmm, yes.
So if I have a laser beam and it goes through a piece of glass, part of it goes through, and part of it is reflected. We've all seen this when light bounces off a clear piece of glass.
Sure.
Okay. So the 2 beams, one beam that went to the left and one beam that went to the right, have information on them. For example, everyone knows that when you go to the drugstore, you buy a polarizer. Polarizer knocks out a lot of the harmful light because light can be in 2 states. It could be polarized up and down or horizontally, left-right. So light beams can vibrate up and down or left and right.
Okay.
So when you split the laser beam, on the left-hand side, let's say it vibrates up and down. This means on the right-hand side, it has to vibrate in the opposite direction. So if it's up on the left, it is down on the right.
Okay.
If it is down on the left, it is up on the right. Okay, the opposites.
Sure.
Now let's wait 10 years. Okay, after 10 years, these beams are separated by 20 light years. We're talking about the distance between stars now. Okay?
Right.
And if you make a measurement on the left-hand beam, and the measurement says it is now pointing up, that means that 20 light years away on a distant star, instantly, you now know that the other beam is pointing down. Okay, polarized down.
Right.
And you can do that with an ordinary polarizer you buy at a drugstore.
Okay.
Okay. Now, Einstein said, now, wait a minute. This violates my theory, relativity, said Einstein. Nothing can go faster than the speed of light. This would be a disaster. The universe would collapse, said Einstein. Well, this experiment was done in Paris in the early 1960s, and sure enough, the world is non-local. Okay? Now, the question is, can you send the Wall Street Journal this way? Can you send Morse code this way? Because, of course, Morse code is did-it, dot, did-it, right?
That's right, yes.
Can you send up, down information faster than the speed of light to the other side of the universe? Okay? That probably is not possible.
Or ones and zeros.
Or ones and zeros, right? And, of course, you could put the Encyclopedia Britannica on ones and zeros.
That's right.
Way, right?
Yes.
So when you make a measurement on the left, you immediately know something on the right. But there's a problem there. There's a catch. So Einstein had the last laugh on this one. And the catch is, just because you know something about the other side of the universe, that is, that the other photon is spin down, it doesn't necessarily mean that you can alter it or send a message this way. It just means you know something about the other side of the universe. And so this is rather bizarre. Here I am sitting in my living room in New York City. My making a measurement here, just looking around the room, I've now influenced something on a distant star faster than the speed of light. My eyeball has made a measurement. It's made a measurement on light coming in from the stars. I now know information about something happening on that star faster than the speed of light. But it doesn't mean I can send a message that way. It just means I know something. It doesn't mean I can send a message that way. Now, we scientists like to put it this way. Let's say you have a friend of yours who wears a pink sock on one foot and a green sock on the other foot, okay?
All right.
Pink sock on one foot and a green sock on the other foot. And he mixes them up every day, so you don't know which sock is which.
I do not socialize with people like this, but all right.
Okay. Let's say one day you look at one of his socks and it's green.
Okay.
This means that immediately you know the other one is pink. But does that mean that you can influence the other sock? Not really. It just means you know something about his other foot. You've never seen his other foot. You've never peeked at his other foot, but you know immediately it's pink.
Right.
Because the first sock is green.
Right.
This means that even though you know something on the planet Earth, that is, the laser beam is pointing up, this means that 20 light years away, you now know that beam is pointing down. Okay? But it doesn't mean that you can send information, usable information, like Morse code or the Wall Street Journal, or, if you could do it this way, you could actually have a time machine this way.
All right.
It doesn't mean you can send you can get tomorrow's Wall Street Journal and invest on the stock market faster than the speed of light, you see. So there's a catch there.
Well, okay? There's a catch, but suppose right now we can't do anything with it, though we know it, we can't do anything with it. But as we make advances in quantum computers, what promise might be ahead there?
Yeah, that's going to be the immediate application. Some people will say, well, what's in it for me? I mean, am I going to get better color television? Am I going to get better cable television out of this? And in some sense, the answer is yes. In the next several years, we're going to be building more and more complicated quantum computers, okay? Now, the reason why we're doing this is because Silicon Valley will eventually become a rust belt. In about 15 to 20 years, you may want to pull your stock out of Silicon Valley because the power of silicon will be exhausted in about 15 to 20 years. Moore's Law will collapse. This means that every Christmas, your toys are not going to be twice as powerful as they were the previous Christmas. Okay?
Oh, no.
Now, that's Moore's Law. You realize that the world's economy is dependent on Moore's Law. That is, that computers double in power every 18 months. We're talking about hundreds of trillions of dollars of nations' wealth comes out of Silicon Valley and Moore's Law, that computer power doubles every 18 months.
That's right.
That's going to collapse. You might as well pull out your stocks because Silicon Valley could become a rust belt in 15, 20 years. And if you visit Silicon Valley then, you may see a gentleman selling pencils on the street, and you'll say to yourself, my God, that looks like Bill Gates.
So it could be like the Pentium 8000, and that would be it.
That would be it. Now, the reason is, by that point, we will be etching on molecules of silicon. And silicon cannot be used as transistors at the molecular level. Silicon is leaky at the molecular level. Electrons do not stay in wires. They leak. They short circuit. So everything short circuits once components become so small that you're now having transistors the size of molecules. A Pentium chip, for example, that you have on your desk,
Yes.
has a layer of silicon about 20 atoms across. That's the smallest layer in your Pentium chip on your desktop, about 20 atoms across.
Okay.
When that hits 5 atoms,
That's about it, huh?
that's about it. At that point, the electron obeys the Heisenberg uncertainty principle. You don't know where the electron is anymore. It jumps out of the wire, and the whole thing short circuits, and your computer don't work. And your toys at Christmas are a big bust.
We know this for sure. We're going to run into this wall.
That's right.
Oh, that's really interesting. All right, so then there's got to be something beyond the wall.
That's right. And that's why we physicists are desperately, and I mentioned this in my book, Visions. I have a whole chapter about the Rust Belt called Silicon Valley. We are desperately looking at laser computers, that is, computers that compute on light beams, as well as DNA computers, computers that actually compute on DNA molecules.
Why is DNA attractive?
Well, think of computer tape. Computer tape is a long series of zeros and ones, right?
Correct, yes.
Now think of a DNA molecule. A DNA molecule is not zeros and ones. It's ATCG. It's a combination of A's and T's and C's and G's, called the nucleic acid. So a DNA molecule is actually more complicated than computer tape. And by cutting the computer tape, by cutting it up and remixing it, you can do calculations on computer tape or calculations on DNA. And this was first proven around 1996 by Professor Adler at Princeton University. He got bottles of liquid containing DNA, mixed them like you do in a laboratory with bottles of water, and he did a calculation that a computer that rivaled the power of a computer. And so we know that you can, in fact, compute on DNA molecules. It's been established for the last 5-6 years. Okay? And the other possibility is the ultimate computer, the computer beyond all computers. The ultimate computer is the quantum computer. And this is where entanglement comes in. Quantum computers compute on atoms, individual atoms. Let's say I have a string of atoms like pearls on a string.
Right.
And I hit a light beam on it. I shoot a light beam, like a laser beam on it.
Right.
Okay. The laser beam will then strike each atom and flip the spin. So an atom is like a spinning top. It either spins up or spins down. Like a spinning top. So it reverses the spin up, spin down, spin up, spin down. It reverses the spin. It changes the spins.
Right.
And then it reflects. That's a calculation. That string of pearls is computer tape. So by hitting computer tape with a light beam, that is a string of pearls, a string of atoms, you've made a calculation on atoms. Now, before you buy any stock on this, let me give you the downside. The world's record, which was set about 2 months ago, the world's record for quantum computing is 7 atoms. 7 atoms. And this computer made headlines 2 months ago when it calculated that 3 times 5 equals 15.
So that's where they are.
That's where they are.
All right,
now,
so
however,
I'm going to leave my stock in IBM alone for a while.
Right.
Then.
Now, the CIA is very interested in this.
They are.
The CIA is literally shaking in their boots.
Hold on, that's exactly. We'll pick up on that point when we get back. Top of the hour right now, Doctor. Back now to Dr. Michio Kaku. Doctor, you were saying that all this quantum entanglement would have the CIA, or does have the CIA, shaking in its boots. Why?
That's right. You see, when the CIA sends super-secret transmissions of code across telephone wires, they have a certain code in mind, and a computer, of course, can break codes.
Right.
But the most advanced computers of today have a very difficult time breaking CIA codes. Now, a quantum computer is the ultimate computer. It's much faster than an ordinary computer, and it can break any known code.
Doctor, by what magnitude? You say it's faster as compared to what we have today, over 2 gigahertz speed. How much faster?
Well, it depends on how big the quantum computer is. Right now, we're only up to 7 atoms. That's the world's record, just set about 2 months ago. In the future, we hope to get to a few hundred atoms, maybe even a few thousand atoms. At that point, we can outstrip a supercomputer. And if, and this is a big if, we can go to a few 100,000 atoms, at that point, we can crack any code known to science. We can do calculations that boggle the human mind. We're talking about the ultimate computing power on computing on atoms in a computer that may be as small as a bread box, because we are computing on individual atoms.
What would be, if we achieved that, what would be mankind's benefit?
Well, immediately, we're talking about cracking codes. That's why the CIA has invested quite a bit of money studying this thing to see exactly how much of a threat it poses. And right now, it doesn't pose that much of a threat because we don't have quantum computers except as toys right now. And like I said, 3 times 5 is 15. That's the world's record calculation for a quantum computer.
Right.
However, eventually, we're talking about maybe approaching artificial intelligence. Now, you're listening to my voice at about 500 trillion bytes per second. That's the rate at which the human brain, an idling brain, processes information.
Okay.
Much faster than anything you have on a tabletop. About 500 trillion bytes per second is the rate of processing of an idling brain.
Wow.
Now, a quantum computer can begin to approach those speeds, okay? And that's why some people say that in 20 years, when Moore's law finally collapses for good, perhaps it's a good thing, because then we won't have robots that put humans in zoos and we're now behind bars and we have to dance every time a robot throws peanuts at us. Okay?
Yes.
So maybe it's a good thing. However, if we have quantum computers, and God knows when we'll have them, if we have quantum computers more than just 7 atoms across, then we may be able to do computations that only the brain can compute at the present time. Our brain has as many neurons as there are stars in the Milky Way galaxy. We're talking about 100 billion neurons, or about 100 billion stars in the Milky Way galaxy. No computer can come close to that kind of intricate cellular network, and the only rival would be a quantum computer. So quantum computers may gradually begin to approach the power of human thought, okay? And this is another reason why people are very much interested in this, because then we could solve lots of problems. We could send robots to the planets, for example, that would be more intelligent than they are now. Our present-day robots have the intelligence of a retarded cockroach. Think of a retarded cockroach, okay, with half a brain, lobotomized, retarded. That's the intelligence of our present-day robots being built at Stanford and MIT. They take about 6 hours to walk across the room. 6 hours to walk across the room. Now, does that remind you of any of your relatives, any of your friends? That long to walk across the room? Well, that's the intelligence of our robots built in our laboratories, and we put them on Mars. We're going to have a fleet of these robots on Mars in the next 5 years.
Yes.
And eventually we'll put them on Europa, a moon of Jupiter, where we think there's an ocean, a real live ocean.
Oh, yes.
Underneath the ice cover of Europa, a moon of Jupiter. And we're going to put robots there, too. So on a scale now of decades, we hope to put ordinary silicon-powered robots on the various planets. But eventually, when we start to have quantum computing, we'll be able to solve problems that at the present time are beyond the capability of a computer.
By the way, I thought we were not supposed to go to Europa. Oh, no, that was a movie.
Yeah.
Yeah, it was a movie.
And
but what about consciousness, Doctor? As we approach such a level with a computer, and it begins to approach the thinking capacity of a human brain, I don't know that we know sufficient amounts about consciousness to be sure that we are not suddenly getting into the God business, the creation business, that we create something with a consciousness. Yes.
Well, we're talking at minimum about 50 years in the future. Okay, so we're not thinking about putting anyone out of business anytime soon. Okay. However, on a 50-year time span, when DNA, laser, and optical and quantum computers start to kick in, then we're going to have to ask those very hard questions about what does it mean to be aware of yourself,
yes,
to be aware of your surroundings.
Yes.
Not every animal, for example, is aware of its surroundings. Monkeys are, porpoises are. You put a mirror in front of a porpoise, and the porpoise will preen itself in front of a mirror. You put a mirror in front of a bug or an octopus, and they want to eat it rather than preen themselves in front of a mirror. So not every animal has self-awareness. Okay?
Right.
And the question is, do computers have self-awareness? And the answer at the present time is no.
Not
They're
yet.
not aware of who I am, where am I, what am I doing here?
Not yet.
Computers don't ask that question yet, right?
Not yet.
Right. But, you know, on a time frame of about 50 years or so, long after Moore's law has exhausted itself and we have this new generation of computers, we may have computers that have that kind of capability to begin to ask themselves that question. Now, my personal point of view is that we'll have silicon consciousness or atomic consciousness. They won't think like us. Our thinking is a byproduct of our evolution on the Earth. We want to know where our next meal comes from, where our next date comes from. We want to know how to relax and have fun and be entertained and have a good laugh. That's our consciousness. Robots may not have that consciousness. They may have a totally different way of looking at the universe than us.
Can we imagine how that might be?
We can imagine it. First of all, they could be dangerous. They may begin to realize that our consciousness is the consciousness that came out of the forest. So we want to learn how to dance and laugh and be amused by television and watch pretty girls on TV and stuff like that. And these robots may say, well, that's a relic of the forest.
Yes.
We don't need these people. So I personally believe that we should put an Asimov chip in their brain. An Asimov chip. In other words, a chip.
Never harm human, right?
That turns them off, that shuts their brains off. Once they start to say to themselves, well, who needs these carbon units? Who needs these flesh and blood units? We silicon quantum-based units are superior. So I think we should put a chip in their brain to turn them off anytime they start to entertain thoughts that perhaps they are, the next stage of evolution, that we are like the Neanderthals to them, and that evolution means that we should give way to the next generation, which is them.
That assumes that we are aware that they're beginning to entertain those thoughts.
That's right. That means that we have to be as sophisticated to read their minds to know that this is a definite possibility.
Well, so then isn't building a computer that is inherently more intelligent, thinking in a totally different way than ourselves, just absolutely inherently dangerous?
Potentially so. Right now, of course, they have the intelligence of bugs, so we don't have too much to worry about.
Right.
However, again, over the decades, they will start to become more and more intelligent. In fact, the Internet will gradually become more intelligent as time goes by. Right now, of course, the Internet has no intelligence whatsoever, right? You ask it a question, it gives you like 100,000 answers. But as time goes by, the Internet itself will gradually become more intelligent, and you'll be able to talk to it. This is the magic mirror of Snow White and the Seven Dwarfs. That's where the Internet is going, by the way. The future of the Internet is a fairy tale. The future of the Internet is a mirror, and you go to the mirror and you say, mirror, mirror on the wall, and you ask it a question, right?
So then actually it's possible that the Internet, as it develops with the new faster and faster and faster and faster and finally quantum computers, could attain a collective intelligence of its own, yes?
Well, this is controversial. There's something called chaos theory. And in chaos theory, order emerges out of chaos.
Yes.
Clouds, for example, all of a sudden condense out of nothingness.
Right.
Storms and hurricanes, which are very regular and quite pretty, materialize out of random motions of molecules.
Right.
These are called emergent phenomena that just by themselves spring into existence.
Right.
And if you look at the world, the whole world is based on emergent phenomenon. As the stars collapse and condense, they form planets, and as planets condense, they form DNA, and DNA forms people, and so on and so forth. So the question is, if you have enough neurons, eventually will they become conscious? Yeah. Now, if you look at the brain has 100 billion neurons, but we only have maybe 50,000 genes. So how is it possible that 50,000 genes, a very small number, can code for the location of 100 billion neurons? And the conclusion is rather staggering. It means that a lot of the architecture of the brain is random. A lot of the brain is randomly slopped together. The genes cannot possibly contain the location of 100 billion neurons.
Now, does that account for why they've actually, for example, removed half of a person's brain? And the person is still functional. It seems impossible. There was
a famous incident of a teenage girl who complained about headaches, and she went to the doctor, and the doctor found out she only had half a brain. She was fully functional with half a brain, and it made neurological history. It's written up in the textbooks.
Yeah, so doesn't that sort of underwrite what you just said?
Yeah, see, the brain is not a standard computer. A standard computer is called a Turing machine, named after the famous mathematician Turing. Our brain is a neural network. And if you ever watched Star Trek, Data always calls himself a neural network.
That's right.
A neural network is a learning machine, which is totally different from a computer, which is a single processing unit of zeros and ones. So a computer is a Turing machine. We are non-Turing machines. We are learning machines. We are neural networks. And neural networks are pretty much assembled randomly, which means that even if you take off half the neural network with a pair of scissors, it still functions. While in a computer, you take out one transistor out of a computer and the whole thing fails.
That's right.
So that's the difference. Remember, a computer is a Turing machine based on zeros and ones, transistors. One component missing and the whole thing crashes, as we all know. A brain can exist with half a brain. You lop off half a brain and it still functions. That's a neural network. It's a learning machine. And it means that large portions of our brains are pretty much randomly put together, okay, which means that the Internet is also randomly put together.
Huh.
And just like a cloud condensing out of chaos, right, emergent phenomenon, some people have projected that far in the future. You know, we're talking decades and decades in the future, when the Internet is many times bigger than it is now, that some kind of collective phenomenon may occur. I mean, consciousness, who knows? But some kind of emergent phenomena may happen in the same way that our brain is constructed, more or less randomly.
Okay, but here's the problem that I see. If the Internet is to one day attain some sort of consciousness, if that might be possible because it becomes essentially a gigantic a neural network.
Neural network, right.
Okay, fine.
Learning machine.
Okay, fine. The whole concept, as I understood it, of the creation of the Internet, which was originally done by scientists like yourself and the government for passing information back and forth, is that you could knock out this part of it, or you could knock out that part of it, like slicing a brain in half, and it would keep on going. You
That's
know,
right.
it would be the Energizer Bunny of the world. It would keep on. You couldn't kill it. And so when you're talking about introducing this this Asmonov chip or whatever it is that would never be harm to humans, how could you turn off something that cannot be turned off?
Well, that's a very good question. First of all, the Internet was created to fight a nuclear war. Okay,
Right.
Many of my friends helped to build the Internet. I've been on the Internet ever since it was first started. And the reason why your email is divided up in so many pieces and then reassembled at the other end, in part is because if Los Angeles or New York are atomized by the Russians in a nuclear war, your email would still go through.
That's right.
Bypass New York, bypass the rubble of Los Angeles.
It would find a neural pathway and go.
And go, right. That's why the Internet was constructed to be very hardy and resistant to a nuclear attack.
Right.
That's why your email has all these headers at the beginning explaining to you where all the different pieces of your email was split up and where all your emails was reassembled.
That's right.
Okay?
Yes.
Now, then the question is, if the Internet becomes like a membrane, a spherical membrane surrounding the Earth, okay? And this membrane has billions of computers. I mean, every human would have maybe a few hundred computers on their bodies and their glasses and their jewelry hooked up to the Internet. We're talking about literally billions of cells basically hooked up on this membrane called the surface of the planet Earth.
Right.
Then could an emergent phenomenon occur in that scenario? Well, if it's a learning machine, then the answer is potentially yes. Okay, if it's a learning machine. Right now, the Internet does not learn. The Internet does not get smarter just because you're on it. It doesn't learn anything. It doesn't accumulate anything, okay? Tomorrow, the Internet is just as stupid as it was yesterday. It didn't learn anything. However, one of these days, a computer programmer will put in chips that make it learn so that it is really smarter tomorrow than it was yesterday. It learned something.
Right.
It learned that when you ask for George Washington, you don't mean a billion George Washington hotels, George Washington high schools. You mean the man, George Washington.
Right.
And so when the Internet gradually becomes a learning machine, and it learns so that every day it is smarter than the way it was before, then you may have an emergent phenomenon, okay? And then you may want to, like I said, pull the plug on it once it starts to get...
I know, but you will have gone too far, and you will not be able to pull the plug, because there is no single plug.
Well, that's a problem. We're going to be very dependent on it. Whole cities will have their plumbing, their sewage system, their electrical output connected to this Internet, right?
Yeah.
And we can't unplug it because then we'll unplug the sewage system and the power supplies and everything that makes our cities work, right? So, but again, in my book Visions, I address this problem But I also say that this is decades away. And as we lay the groundwork of the Internet, let us keep some of this in mind.
Well, let me tell you something, Doctor. I interviewed a man last week, a scientist in Great Britain, who is having a chip transplanted into the neural network of his arm. That he...
Yes, I've met him. I had dinner with him once.
Well, son of a gun. I interviewed him for several hours, and his plan, he's about a week or two away from having the second chip implanted, as you know, then.
His wife is going to be implanted.
That's
I talked to his wife.
That's right. And do you know what he's going to do? He's going to hook himself up to the Internet.
However, when I talked to him, I asked him the key question, and that is the chip hooked up to his nervous system? And the answer is no. The chip is not wired to the brain. So in some sense, it's an isolated system. It's a system that is embedded in the skin. It's not hooked up to the central nervous system. Now, when that occurs, then, of course, all sorts of stuff is going to hit the fan once we start to connect chips to the central nervous system.
Yes.
Now, right now, we can do that with squid neurons. Squid neurons are actually visible with the human eye. The human eye can actually see the neurons inside some sea animals like squid. So we've actually connected a chip to a neuron of a squid and actually sent messages. You can actually send Windows software right through the neuron of a squid.
You're kidding.
This has been done already. It was done in Germany at the Max Planck Institute. We can actually take messages out of the neuron of a squid and then process it and send Windows back in the neuron of a squid, which are quite visible. And
That's incredible. Doctor, we're at the bottom of the hour. Hold on. Dr. Michio Kaku, one of the world's greatest theoretical physicists, is my guest, and we'll be right back. Oh, very interesting. Emu, somebody calling himself Emu in Philadelphia says, Squid can run Windows? Is it Windows 98, NT, or XP, and what happens when it crashes? And oh, by the way, does the Justice Department know about all of this? Doctor, I want to ask you about, and see if this fits into what we've been talking about. Princeton has been doing this really interesting experiment in which they have placed all kinds of computers at different locations around the world. They call them eggs, and these computers are spitting out random numbers. They are random number generators, or at least, I guess, as close as you can get, random number generators. Now, these eggs, as they call them, feed all the information back to a mainframe computer at Princeton. Now, they're not talking a lot about this, but Doctor, I've seen some graphs of what happened in New York on September 11th, and an interesting phenomena occurred. They have a graph that shows these eggs reporting the randomness as sort of a line on a graph, and then about 4 hours prior to the 9/11 event, the graph began to take up off out of the noise level. And the randomness began to become non-random to the point where when the event occurred, it went right off the chart and then slowly went back down again. And they have been charting world events and looking at the results of these eggs, they call them, reporting. And they've had many, many instances of correlating world events with the sudden the stopping of the normal randomness that the eggs would be reporting. What do you think they might be seeing?
Well, I haven't heard about this experiment. However, there have been some experiments done at the Princeton Mechanical Engineering Department where they've tried to see whether or not human consciousness or people thinking can influence the outcome of mechanical events.
Yes.
Think of throwing a bunch of steel balls down a bunch of pins, random set of pins. Then, of course, the ball, like in a pinball machine, right, should bounce randomly, and at the very bottom of this whole series of steel pins, you should get a mountain of steel balls.
Correct.
And the question is, by thinking, can you alter the distribution?
Yes.
Well, there is a professor there who claims that it may be possible to skew some of these results, that you're not going to get this perfect distribution, mountain-like bell-shaped curve, right?
Right.
However, other people have not been able to reproduce it, and that's the key. the science is based on reproducibility. So even if, for example, you claim to have a cold fusion device in your car and a glass of water energizes your car, you have to make sure that when you mass produce these cars, that every car turns on exactly at the same time in the rain, the snow.
You bet.
It's reproducible, right?
Sure.
So these experiments, done at Princeton, showing that thinking or people's feelings can influence the motion of steel balls, has not been duplicated in other laboratories around the world. That's not to say that they didn't find something. It's just to show you that it's a very ephemeral effect, and it's quite difficult to reproduce. So I would believe it if you could get other random computers with random number generators to hook up to show you that different kinds of catastrophic events can influence seemingly random motions.
Well, the interesting aspect of that graph, and it would really knock your socks off to see it, is not so much that it went off the charts when the event occurred, it's that it began going off the charts 4 hours prior to the event.
I see. Do you have like a web page for this? I'd be more than happy to look at it.
If my webmaster was at home, he's en route right now from
send
Texas.
me email then, and just
I would be glad to do that. But I mean, you must admit that's very interesting when you're talking about a non-locality, a non-local universe, that there could be an anticipatory rise prior to an event of that sort would suggest all kinds of interesting things about time and...
Right. Well, you see, at the quantum level, things like this are commonplace. At our level, at the macroscopic level, we're big, right, compared to atoms. It's quite rare. It's probabilistically extremely small. But at the atomic level, things like this happen all the time. Like you really don't know the state of an electron until you look at it.
I'll tell you what. Let's make this easy. I know that you have a public email address that you give out, right?
That's right.
Let's give it out, and I guarantee you will get so many charts.
Okay.
What is your email address?
Well, mkaku.org. mkaku.org is my webpage, and my email address is on it.
Oh, by the way, I'm getting a lot of Fast Blast computer messages here as we're on the air saying that there are a bunch of people in, I guess you have a chat room on your website?
That's right. People can chat on my webpage.
So I guess they're in there right now talking, and I imagine now that we have mentioned it, there are going to be a lot of people in there. That's mkaku.org.
Yeah, mkaku.org, right. There's a chat room there, so you can be in contact with other people who like to talk about these weird things.
And that's going on right now, folks, if you've got a computer. And we've got a link to mkaku.org on my website if you want to go that direction, right under Dr. Kaku's name. Okay, so... back for a second to this internet, because I wanted to finish up there. Here we have this professor getting ready to put the chip in. It's the first step. How do you look at the possibility of eventually humans interfacing directly with the internet?
Well, I think that there's nothing technically preventing it. There are technical hurdles. For example, the human neurons are very small compared to squid neurons. They dry up very quickly. You have to bathe them constantly in fluids and nutrients. They're very hard to keep alive, human neurons. But there's no stumbling blocks. There's nothing in the laws of physics that says you can't hook up the central nervous system to a chip. The problem is we have not deciphered the spinal cord. Think of all the cables that go into New York City. If you were to cut all the cables that went into New York City and you were to have to re-splice them, it would take you 100 years to try to figure out where each wire went into another wire into New York City, right?
Sure.
Well, the spinal cord is 1,000,000 times worse than that. These are microscopic cables. And it'll take quite a while before we can begin the process of figuring out which neuron connects to which muscle in which part of the brain. And it's a question of deciphering it, okay? Now, of course, you can stimulate one part of the body, and then that stimulates a part of the brain, right? But how you trace that with your instruments is extremely difficult. So the question of cyborgs, okay, there's nothing in principle that prevents you from having a cyborg like in Terminator 2, okay? By the way, one restriction to cyborgs is the human skeletal system. You can create a human arm that's mechanical, that is perhaps 100 times more powerful than our arm, or a human leg that can run much faster than our leg, like in the Bionic Man.
Yes.
The problem is our bone structure is very weak. And if you try to lift a car, with these mechanical arms, your mechanical arms will do just fine, except your spine will break. So you have to have an exoskeleton. So when we go into outer space, and when we have to do dangerous missions on the asteroid belt or things like that, then we may want to, enhance our mechanical capabilities. And then we'll have to have an exoskeleton, because our skeletal system won't support superhuman kinds of feats.
All right. Check this out. I read a story. It's from The Guardian in Great Britain last night. It sounds crazy, the stuff of science fantasy, but a respected American surgeon says that within 5 years, he will be able to graft wings and tails onto human beings. His name is Johan Hari, and he's a plastic surgeon. And here's what he's saying. He's saying he can put wings on humans, and that in the same way that when you have an arm cut off, your pathways, your neural pathways, are still telling your brain that limb is there. You have the shadow limb effect. And he claims that he could move human fat out and take some rib structure and build wings on a human being, and that as time went on, the opposite process would occur and neural pathways would actually be formed.
Well, yes and no. First, let's look at the biology, then let's look at the physics.
Okay.
First, you have rejection mechanisms, because you're talking about animal proteins, which are foreign proteins to our immune system, and our immune system recognizes foreign proteins, like the proteins in animals. So they would be in a rejection system, so you would have to suppress it with drugs.
Right.
You have to suppress the immune system.
Well, we do that now for transplants.
Then you would have to hook up the neurons. And, of course, hooking up neurons is no easy feat. These are invisible with the human eye. Attaching them can be done. We've done it, there have been reports of, people's arms and limbs cut off.
Absolutely.
We've been able to reattach them.
Yes.
So if you could somehow get rid of the rejection mechanism by drugs, suppress it, then in principle you may be able to hook up the neurons. But then, of course, the coding of the neurons could be slightly different. We have to match the neurons to make sure there's a compatibility between the neurons of a human and the neurons of an animal. Okay? So, and then we would have to learn how to wiggle it. We would be like children learning how to walk.
But would it be possible for a new, once you had done some work, for new neural pathways to actually develop?
Yes, neural pathways develop, and they re-innervate themselves. They grow. Okay?
Yes.
Now, this does not mean that you're going to be able to fly, because even if you had the wings of an angel that is much larger than that of an eagle,
right?
Okay, your muscles are not powerful enough to make you fly. Birds have hollow bones, first of all.
Yeah, well, he actually says that. He says he doesn't think humans could fly, but he can definitely put functional wings on a human.
That's conceivable. I mean, if you can, again, suppress the immune system, B, have the compatibility between neurons to be worked out, C, you would have to learn like a baby, how to wiggle that tail, wiggle that wing, then in principle it could be possible. But again, right now it is beyond our surgical capabilities. But 5 to 10 years is a time frame that is, sort of realistic, I think, if you could overcome those hurdles that I just mentioned. Okay?
So then it's not impossible, though, that neuron pathways could begin to form. That was kind of basically my question.
That's right. In fact, on a stroke victim, this was done in Atlanta, Georgia last year. A stroke victim had a neuron, a piece of wire placed in the brain. The nerves grew into the glass bead, which then had wires coming out. The wires was hooked to a laptop. And the person, by thinking, was able to move the cursor on a laptop.
Oh, I just read that.
That was done at Emory University in Atlanta, Georgia, last year. So it is possible for a direct brain-laptop connection.
Yikes.
Okay? Again, the person had to learn like a baby. There's no manual for this.
No, I hadn't even read this to my audience yet. I have this story. It just broke. But it's true. The person was able to actually control a cursor, as you would control a cursor with a mouse, but by thinking the cursor around.
That's right. He was semi-paralyzed, and the chip was put into a sort of like a dead area of the brain.
Oh, that's incredible.
And the person is, like I said, partially paralyzed, and yet the person's able to think and move the cursor on a screen.
Wow.
Which means that eventually the person will be able to move his own wheelchair, perhaps even move arms and legs that are mechanical by thinking about it, even though certain parts of his central nervous system have been destroyed by a stroke in the brain, you see. So it is possible to, A, have neurons grow into a glass bead and connect to metal, okay? B, it is possible to learn like a baby, like a neural network, learn like a baby how to control that cursor on a screen. And then C, you'd be able to control mechanical devices by thinking about it. Okay?
But then way down the line somewhere, is it not inevitable that man meets and merges with machine?
Okay, this has been proposed for the far future now. Now we're talking centuries in the future.
Sure.
That instead of robots being an enemy, why not merge with them and become immortal?
Yes.
In other words, why not wake up one day and find ourselves immortal in a silicon body? Okay? So let's say, again, centuries in the future, our descendants get old and they don't want to die. They know that flesh is frail and flesh will eventually die, but silicon does not.
Right, right.
Then you would, the surgery would have to replicate the neural structure of each neuron into silicon. So they would take out one silicon piece, one piece of neurons, and duplicate it on another table, a piece of silicon.
Kind of like transferring the contents of one hard drive to another.
Right, and you would be conscious during this whole process. You would be wired up. So as parts of your brain are removed, there are wires connecting you to this other part of the brain. So half your brain is on the other side of the table, half your brain is inside your body, and you're conscious. You're fully conscious during this whole process.
Kind of like Rush Limbaugh.
Yeah, and you don't feel a thing. Eventually, all your neurons are then transferred into silicon on the other tabletop. And when you wake up the next day, you have a silicon body. You are immortal. You will live forever.
So in other words, the total you, your consciousness, your thoughts, your memories, everything that is you is now not in two places, or is it in two places?
Or in one place.
It's in one place. It has been transferred to silicon.
Right, because half your brain is made out of silicon on the other table. You are still sitting on your tabletop with half your brain missing. Okay, and again, this is centuries in the future.
Yes.
Don't try this at home, folks.
Yeah.
And it means that you're fully conscious during this process, because half your thoughts are on the other side of the table. But eventually, your brain is transferred fully to the other side of the table, where there is a robot waiting, an empty robot with no brain.
So then, kind of like the computer in 2001, you would slowly begin singing nursery rhymes toward the end.
Right, that was a neural network that was gradually disconnected.
Yes, right.
A lobotomized neural network.
Well, isn't that roughly the same process we're discussing here?
Yeah, here we're doing the opposite. Instead of lobotomizing it, we're essentially assembling it on another tabletop. While you are conscious, fully conscious, you don't feel a thing.
You wouldn't feel yourself slipping away?
No, you don't feel a thing. And your consciousness is just as sharp as ever. Your thinking process is identical to your normal thinking process, because neuron for neuron, every neuron that is deleted from your brain is then transferred into silicon on the other table.
Wouldn't every neuron then, once transferred, be saying you still have a physical body? Wouldn't you feel every part of that physical body?
Well, all your neurons are connected to your central nervous system, so you would still feel everything.
Yes.
Even though half your brain is on the other tabletop inside the body of a robot.
Yikes.
You would still feel everything in your body until the final switch. The final switch is then made, whereby you have nothing left inside your cranial system, but everything is in silicon on the other tabletop.
And so you are now
fully conscious inside the body of a robot.
I understand, but what you were is now just lifeless.
It's going to die anyway. It's very old. It was going to die anyway. So it's a way of preserving every single neuron, every single neural network inside your brain, inside silicon, so that you will live forever and become immortal.
Professor, you live in a very intellectual world. Given the opportunity to do something of that sort toward your own physical death, what decision would you make?
Well, I wouldn't mind living a few hundred years. I don't think it's going to happen in my lifetime.
Minus the physical body, just the intellectual you left.
Well, I personally think that that's perhaps the greatest joy of living, is to be able to see, experience new sensations, have new kinds of thoughts. And again, this scenario that I laid out is centuries in the future, but there's nothing in the laws of physics that prevent immortality if there's a merger between carbon and silicon. So some people have said that the future is not carbon. The future is a merger between silicon and carbon, and that will give us immortality. And, by the way, if we meet aliens from outer space,
yes,
okay, who are, millennia ahead of us, then they may have already made that transition. They may already be half robot, half flesh.
That would account for some of the sightings we've had. Hold on, Doctor. We're at the top of the hour. Doctor, welcome back. As I said, there's a remake of the H.G. Wells film that actually is already just now hitting the theaters, proving and just blasting up the charts, proving how many people are totally fascinated with the concept of time travel. Do you think it will ever be actually possible?
Well, we physicists think that time travel is theoretically possible. Not necessarily practical, but we do think that if you use Einstein's equations, there are literally hundreds of solutions that we've discovered which allow for time travel. Now, think of time as a river. Time is a river that curves and meanders and speeds up and slows down. It's like Old Man River going throughout the galaxy. However, the new wrinkle on this, and this is what's creating all this excitement among physicists, is that the river of time may have whirlpools, and the river of time may fork into two rivers. And if the river of time bends on itself, perhaps we can bend it like a pretzel and bend time back on itself to perhaps meet yourself before you're born, or meet your parents before you're born.
Oh, really?
And, of course, this, invites all sorts of paradoxes and things like this. But we physicists have found that if you have enough energy, enough positive energy or negative energy, you can use Einstein's equations to open up gateways, holes, portals, by which you can then travel backwards or forwards in time.
Would travel in one... so many people are saying traveling forwards in time would be perhaps easier than going back.
That's correct.
Oh, it is correct.
Yeah, traveling forwards in time can be done with a rocket ship by traveling near the speed of light. Time slows down for you in the rocket ship, so it may take you, for example, just 1 minute to reach the nearby stars. On the Earth, looking at your rocket ship, you're frozen. You're frozen for 4 years traveling near the speed of light.
Right.
But you in the rocket ship only sense that you've been in the rocket ship for about 1 minute. So it's like suspended animation. Okay, except without the freezing. But you have to get near the speed of light. So in the movie Time Machine, if you had a rocket ship that could then speed for 800,000 years near the speed of light and then land back on the Earth, for you, it would only have been maybe just 1 minute. But for the Earth, it would have been 800,000 years. So going forwards in time is not so difficult. Subatomic particles do this all the time. The question is, can you go backwards in time?
Right.
That's the killer. Okay. Now, if you go backwards in time, that requires a whirlpool, or what we physicists call a closed time-like curve. That's the scientific name for time travel.
Okay.
So if you see in the literature CTC is how we physicists talk about time travel, because, of course, we don't want to be deluged with all sorts of science fiction fans asking us questions. Now, if you could open up, for example, a black hole, or if you could amass enormous amounts of what is called negative energy, then you could open up a gateway by which you can then travel backwards in the past to perhaps meet your parents before you're born. And then, of course, the question is, what happens if you go backwards in time with a gun?
The paradox.
And kill your parents before you're born.
Of course, yes.
Then you're in deep doo-doo. Then, of course, you've killed your parents before you're born, so how could you be born?
But there is an answer to the paradox, isn't there?
Yeah, there are two answers that we physicists are seriously looking at, okay? The first proposal I don't particularly like, but it's by a Russian physicist, Professor Novikov in Moscow, and he's a very well-respected authority in Einstein's equations. And Novikov believes that when you go backwards in time, you, in some sense, fulfill the past. It was meant to be. It was written that in the past, some traveler from the future landed in the past and amazed all the villagers. So it was meant to be this way, that in some sense you fulfill the past. So time sort of becomes circular. So that if you go backwards in the past, there is something that prevents you from shooting your parents before you're born. Okay?
That's one.
That's one way. The other way, which I prefer, is that the river of time forks into two rivers.
Right.
This means that a quantum universe opens up. Just the way the quantum universes open up for atoms all the time, a quantum universe opens up so that when you shoot your parents before you're born, you've actually shot somebody else's parents who are genetically identical to your parents. They look just like your parents. They have the memories of your parents. They have the genes of your parents, but they're really not your parents. A parallel universe opens up.
So, boom, we have just, with that shot, created another universe.
That's right. By going backwards in time and by shooting your parents before you're born, the river of time forks into two rivers, so there are no paradoxes. Okay? No paradoxes at all. But this means, of course, the price you have to pay is you have a multiverse. Because you can go backwards in time any number of times, right? And this means that the river of time would fork into many tributaries. And it means you have a multiverse of universes. Now, if you read the scientific literature today, most cosmologists believe in the multiverse idea. Most cosmologists believe that our universe is a bubble coexisting with other bubbles, and that these other bubbles may look just like our bubble, except one quantum difference between our bubble and the next bubble.
Back to quantum.
Yeah. For example, let's say that a cosmic ray went through Churchill's mother, and so Winston Churchill was never born to oppose Adolf Hitler, which means that one quantum event separates us from a world where the Nazis defeated England and went on to defeat the United States. And we're speaking now today in German rather than in English. Okay? One cosmic ray separates us from a world where we're speaking in German today, talking about these things.
By the way, I think, I'm sorry, I'm terribly sorry, but I think your chat room just developed another bubble and went into another universe. It looks like just mentioning it has murdered your chat room temporarily.
Oh, it's been flooded with guests from the future. We're taking in on the past.
That's right. I know black holes also play a part in the concept of... incidentally, I've been hearing rumors on the Internet that there are some Russian scientists working on some aspects of time travel. Have you heard anything about that?
Well, this is Professor Novikov. He's written quite a few articles about this. In fact, one article just came out last month, an article that he wrote with Stephen Hawking, talking about how the Russians view time travel. That the question he's asking is, what happens if you went backwards in time and told Eve not to eat the apple? Well, if you told Eve not to eat the apple, then of course humans were never expelled from paradise.
That was actually Adam that ate the apple, I think. Eve fed it to him.
Oh, fed it to Adam, right? Yeah, so however, what happens when you go backwards in time and you meet Eve, giving the apple to Adam?
Yeah.
Then there must be some kind of force preventing you, some kind of accident, some kind of mishap, preventing you from Adam getting the apple from Eve. Okay, so this is an article he just wrote, and this means that there's no free will. That in some sense you're like a robot when you go backwards in time.
Boy, have I struggled with that one.
Right. Now, however, I personally believe in the other point of view, the point of view that is gaining dominance in the world of quantum cosmology, the world that of science where we believe that there's a multiverse. And then there are no paradoxes. There are no paradoxes at all. The river of time continues to fork every time you go backwards in the past. Okay. Huh. Now, Stephen Hawking, if you go to the London Museum in London, there's a wax image of Stephen Hawking saying that time travel is impossible because where are the tourists from the future?
Yes.
However, he's now retracted that statement. His wax image may keep on saying that, but in real life, he's retracted that statement. He now believes that time travel is possible, but it's not practical because the energy necessary to open up this gateway is the energy of a star. And we would have to be at least type 3.
Or a black hole.
Or a black hole. Either you have lots of negative energy or positive energy. A black hole would have lots of positive energy, for example. And you would have to be probably in a very advanced type 2, or more likely type 3 civilization, before you can manipulate and play with black holes the same way that we play with billiard balls on a table. Once you have that kind of power that you can juggle black holes, then perhaps you can have gateways to the past. Okay, So, and again, we think that going through a black hole, you disintegrate, you die, you don't go through. But actually, black holes are spinning, and they're spinning very rapidly. We photographed over 50 of them now with the Hubble Space Telescope, and they're spinning very rapidly so that the black hole does not collapse to a dot. It collapses to a ring of neutrons. And this ring of neutrons is spinning very rapidly. That's why it doesn't collapse. Centrifugal force prevents it from collapsing. And if you fell through the ring, you're falling through the looking glass, the looking glass of Alice, which connects Oxford, the countryside of Oxford, to Wonderland.
Just like Contact, the movie.
It's like the movie Contact. So a wormhole machine and a time machine are basically the same thing. Okay? A wormhole will connect you to a distant point in space. A time machine connects you to a distant point in time, and they are basically the same.
Okay, I have dominated you. Let's let a few people get in here and ask questions. First time caller line, you're on the air with Dr. Kaku. Hi.
Hey, how you guys doing?
All right, sir. Where are you?
Actually, I'm in Phelan, California.
Okay.
And I actually had two questions. Is that all right?
Sure.
Yeah, my first question was about the quantum computers. Would there possibly be, say, quantum computer that could use millions or billions of atoms that could actually use extreme abstract calculations, something normal computers can't do, to solve, say, like the unified field theory or something in a couple of microseconds?
Right.
Now, is abstract calculation possible with that?
Okay, yes. It turns out the quantum computers can do calculations that ordinary computers cannot do. Quantum computers can compute quantum calculations. It takes an infinite amount of time on a computer to perform some of these calculations, an infinite amount of time. On a quantum computer, it would take a finite amount of time, perhaps seconds, to do a calculation. So that's one reason why we physicists dreamed up this idea back in the 50s, because we realized that certain quantum calculations take an infinite amount of time on a computer. So why not create a quantum computer that can do a quantum calculation in a finite amount of time? That's why we dreamed up this idea back in the 50s. Okay? So the answer is yes. We may be able to do calculations that are useful for the unified field theory on a quantum computer that would be impossible on an ordinary computer, because it would take an infinite amount of time on a regular computer.
Okay.
The CIA is interested in these things.
Oh, I bet.
So are we physicists.
Yeah, I bet they are.
Yeah, my second question was, are you familiar with any of Dr. David Anderson's work?
No. What has he done?
Actually, he's claimed, along with a few others, that a properly modulated electromagnetic field produces a secondary field inside of itself that actually, when you adjust the frequencies, can affect the flow of time. Either slow it down or speed it up, only to a certain point. Reversing it, actually, they've hit a wall in that area, but they've actually put candles and actually watched them melt faster. Old-fashioned clocks tick faster until it I believe it's called the Doppler shift, happens, and everything inside the secondary field goes black. And this is using, a few thousand volts, I believe. But, this would sort of negate the usual physics, saying that, the amount of energy amount of a star, a black hole, would be needed for a small amount of time warping.
Yes, well, you're correct. The standard physical interpretation using Einstein's theory is that it takes the energy of a star to be able to warp time and slow it down to the point where candles burn slower. Now, we've measured Einstein's theory on the moon. It turns out the time beats faster on the moon than it does on on Earth. So you have what is called gravitational redshift, and so we've been able to prove that time beats at different rates compared to different gravities. So the more gravity you have, like on the Earth, the slower time beats. So the time beats slower on the moon than it does in outer space, for example. Okay? Now, in order to slow down time where you can actually see it with the human eye, the standard interpretation is you would need the energy of a star to do this. Now, with the Hubble Space Telescope, we have now been able to confirm that Einstein's theory is correct to 99.7% accuracy. That's well within experimental errors. I repeat, some people think that Einstein's general theory of relativity is only good to maybe 10% or 20%. We've been able to verify it to 99.7% accuracy.
Good.
That could actually be 100%. Okay, we've seen no deviations from Einstein's theory. So I haven't seen this result, but it does seem to contradict what is commonly known about gravity, which, like I said before, is now been confirmed by the Hubble Space Telescope. Gravity bends light. Gravity can act like a lens. All these effects predicted by Einstein have been confirmed to 99.7% accuracy now.
And gravity we know to be a function of mass?
A function of mass, and gravity is an illusion created by the bending of space. So gravity, in some sense, is an optical illusion.
Huh.
Shakespeare said that life is a stage, and we are all actors on a stage. But if the stage were hilly, if the stage had bumps on it, and you were to reenact Romeo and Juliet on a stage that was curved, you would say that there's a force acting on you. You can't walk in a straight line. You cannot walk straight. There's a force acting on you. That force is equivalent to gravity. So gravity is a consequence of the folding and the bending of the stage of space itself, which is invisible, of course. And this has been verified to, like I said, to enormous accuracy now with the Hubble Space Telescope.
Okay, let me ask you about perhaps a little problem in this area. We've got some spacecraft, the early Pioneer spacecraft,
right?
That are just really out there now and
way beyond Pluto.
Oh, just really moving. Except for one little problem. They're slowing down.
Mm-hmm.
And nobody understands why. I mean, it's like they're hitting this something or another that's beginning to slow these spacecraft down.
Mm-hmm.
What do you think that might be?
Well, I don't know. I'll have to look into this. There are solar winds out there, and our solar wind goes out, for example, almost a whole light year.
I think it's beyond that. In other words, they've accounted for that, and they cannot account for the slowdown in the spacecraft. It's a very interesting...
I see. Well, I don't know. But the Voyager spacecraft have left the solar system and have actually given us a family picture of all the planets together. One family photograph of all the planets together.
Isn't that incredible?
Compliments of the Voyager spacecraft.
Doctor, hold on. We're right at the bottom of the hour. We'll be right back. I'm Art. Well, we've only sent about 1 million people over to Dr. Kaku's website, and one of them just commented on the website, I think quite accurately. The good doctor always references Star Trek, quite frequently references Star Trek, and somebody has noticed a striking resemblance between yourself and Sulu.
Uh-huh. Well, I guess there is some resemblance.
There is, kind of, actually. Okay, onward we move. First-time caller line, you're on the air with Professor Kaku. Hello.
Yes, I'm Kara from Denver, listening on KHOW. I had a question about Tesla and Einstein. I understand from actually the After Dark newsletter that the Tesla's unified field theory was placed in front of, or maybe they actually met, I'm not sure, in front of Einstein, and he could not understand it. He could not make heads or tails, and I wondered if you might be able to comment on that, Dr. Kaku.
Well, I have the complete works of Tesla in a book that came out recently. And Tesla, of course, was this genius that came out with radio frequency generators, and he also pushed alternating currents, while Edison was pushing direct currents. And we all know who won the battle between Tesla and Edison. It was Tesla. And every time you put a thing into your wall socket, you owe a debt to Nikola Tesla. Now, Tesla had some ideas that were very prophetic, and also some ideas that haven't panned out yet. He thought, for example, that you can get energy from nothing. And that idea was poo-pooed for many years. But now we know from the latest cosmology experiments and the data from our satellites that nothingness has energy. It's the energy that is accelerating the universe. The universe is expanding, and it's actually accelerating right now. And the acceleration of the universe is due to the fact that there's anti-gravity. This energy of nothing is pushing the galaxies apart. So this development is only about 2 or 3 years old, but it's the biggest sensation in cosmology, the fact that the universe is expanding very, very rapidly. So that's sort of like a combination of some of Tesla's ideas of the energy of nothing put into Einstein's equations, because Einstein also had that idea back in 1917 with his cosmological constant theory.
Professor, is it possible, and I've heard, as many people have, many things about what Tesla reportedly did, and I'm sure there's myth that's grown out of it, but there's some substance, apparently, to his having either grabbed energy from essentially nothing or transferred energy through the air in a way that we're just as you mentioned, beginning to come to grips with the possibility of now. Could he have done that then?
Well, it's not clear. He thought, reading his works now, not just hearsay, but actually reading his works.
Yes.
He thought that you could actually generate usable energy that you could then use in your kitchen, for example, out of nothing. That nothing was a storehouse of vast amount of energy. Today, we physicists call it zero-point energy, and we can actually measure it in the laboratory. It's called the Casimir effect. It's very small in the laboratory. However, in outer space, there's a lot of it, and it's enough to push galaxies apart. So whether or not Tesla himself realized the full implications of this is not clear. Einstein did. Einstein actually put this term into his equations in 1917, and now we realize that this is perhaps the dominant form of energy in the universe. The matter you see around you is only a tiny fraction of the amount of dark energy that we see around us. So dark energy is another word for zero-point energy, which is another word for Tesla's energy from nothing. Today we call it dark energy.
So then there is the possibility that he was actually doing what we're just beginning to come to grips with at the moment.
Well, he thought we could get usable energy, like energy that would drive our refrigerators and our TV sets and things, right?
Sure.
However, so far, we've only found that it's very small. It's very tiny. It's measurable in the laboratory. It's called the Casimir effect. But in outer space, there's enough of it in outer space to drive galaxies apart.
But, there's enough. We've discovered enough that the poo-pooing has stopped.
Well, we have to take some of his crazy ideas more seriously. People laugh at the idea of the energy of nothing. How can nothing have energy?
Yes.
And now we find out that it's the dominant form of energy in the universe. You can go to any physics journal on the Earth now, and read about dark energy, and there it is. It's perhaps the dominant form of energy in the universe. It's perhaps 100 times more energetic than the amount of matter that you see around you. So when you look at the 100 chemicals that make up the universe, the elements, realize that is only a fraction, about 1%, of the actual energy of the universe, which is dwarfed by something called dark matter, and which in turn is dwarfed by dark energy, which is the energy of nothing.
Well, of course, we all know that Tesla's documents were seized. I mean, the government came rushing in and took all he had and took it away someplace or another.
Yeah, unfortunately, he did not have a team of lawyers to prevent Sarnoff and others from ripping off a lot of the patents, which are now, of course, part of radio and television. Unfortunately, he was kind of an eccentric. He lived at the New Yorker Hotel. He lived out of a hotel room, and he thought he was being poisoned by his enemies. And so he was quite paranoid. And his problem was that he didn't have a team of lawyers to protect the patents, which many people feel were stolen from him. But you see, we physicists know what he actually did, right? So we, in his honor, have named the unit of magnetism after Tesla.
Indeed.
So when you go to an MRI scan, and the MRI technician says that they're going to put 1 T worth of magnetic field around your brain, right?
Right.
What does T stand for?
Tesla.
Right.
Yep.
The next time you have an MRI scan, you owe it to Tesla, because the Tesla is now the unit of magnetism.
Well, in my case, I owe a lot to him then. Wildcard line, you're on the air with Dr. Kaku. Hello.
Hello?
Hello, where are you?
I'm in Bozeman, Montana.
Yes, sir.
This is a little bit off kind of the subject, but it's kind of been building up to this question. I was kind of inspired by the whole wings thing that you guys got going on.
Oh, yes.
And I've been talking about this kind of subject with my friends for the last couple of weeks, and we've been kind of deciding that, with this whole terrorist attack and what's happened in the last, year and whatnot, people are going to be kind of ruined for flying cars and all these, aspirations to the future because of security issues. We don't want just anybody up in the sky flying, or at least we don't right now anyway. So then I started wondering, what measures could we take to prevent this? And I started thinking of, science fiction movies and stuff where they have force fields, like in Star Trek and stuff where there's shields and force fields and things that can prevent things from damaging things. And I'm just wondering if anybody could answer that question. It'd be the doctor here. Is this kind of technology possible? Could we...
Actually, it's a pretty good question. In other words, could force fields be eventually some sort of reality, some sort of protective force fields, some giant force field over New York City that would prevent the kind of thing from happening that occurred? Or
Well, when teenagers watch Star Trek, they think that force fields are easy. I mean, everyone has them. The Klingons have them, the Romulans, so everyone has force fields. But you see, there are only 4 forces that we physicists have been able to identify in the universe. Gravity, electricity and magnetism, or light, and then there are the 2 nuclear forces, the strong and the weak nuclear force that lights up the sun.
Right.
These 4 forces do not seem to conform with the concept of a force field. Take a look at gravity. Gravity is attractive. It's very weak. It's very attractive. Force fields are repulsive. So gravity has to be ruled out. Electricity and magnetism have to be ruled out because plastic will go right through a magnetic field. You can have an electric field or magnetic field and throw a piece of plastic, and it goes right through both. Okay? So electricity and magnetism has to be ruled out. And the nuclear force are very short range. They only work on the distance of the nucleus, which is, of course, a teeny-weeny fraction of the size of an atom.
Sure.
So it's very difficult to do anything with a nuclear force other than unleash it in the form of a hydrogen bomb or a star. Okay? So at the present time, believe it or not, we physicists don't have a clue as to how to build a force field. See, we have a working model for a time machine. You just have to have enough gasoline to propel it. But we have no blueprint for a force field.
Interesting.
So the simplest object in a science fiction story could be the hardest to produce, a force field.
So until we perhaps tap into this new energy and understand more about physics, no force field.
That's right. At the present time, with our limited primitive knowledge of physics, we don't have a clue as to how to build a force field. Now, this doesn't mean that in 100 years we can't find new fantastic discoveries. But as of the year 2002, we do not have enough information about the laws of physics to create a force field.
That was a very good question. All right. East of the Rockies, you're on the air with Dr. Kaku. Good morning.
Hello.
Hello.
Yeah, first thing, Mr. Bell, I got to tell you, you have the world's greatest bumper music.
Oh, thank you.
I am on the left coast of the right coast,
okay.
Florida. Al, listen to you on WFLA 970.
Yes, sir.
And originally, I was when I first called, I was listening to. I caught a bit of what Dr. Kaku said about transferring the brain into a robot.
Oh, yes.
I know we've drifted considerably.
That's all right. What is your question?
I would think the ideal person for that would be Stephen Hawking.
Oh, well, yes, indeed. Doctor, he makes a good point. In other words, I would imagine that once that technology would become available, the very few incredible brains like we have, we have so few, and that's a good question unto itself, really. We have Stephen Hawking, we had Einstein, we have you, and we have a few others, but the numbers are awfully small. Are we evolving, continuing to evolve as a human race, and why do we have so few Einsteins?
Well, the human race as a race is probably not evolving at all anymore. Anyone can have children. Anyone can go across continents with an airplane. There are no more bottlenecks like Australia that would accelerate evolution. So our evolution has pretty much been stopped. What you see is what you're going to get 100 years from now, unless we tinker with our genes, okay? However, if you take a look at Einstein's brain, which has been preserved, as you know, and scientists are now beginning to look at it very carefully, we find that there are anomalies in Einstein's brain. There was one part of the brain that deals with abstract thoughts, visualizations of abstract things like equations and things.
Right.
That was highly developed in Einstein's brain. Now, of course, it's difficult to, make sense out of this information, but one part of Einstein's brain that dealt with very abstract thought, the kind of thinking that you need for equations and things, is very developed in Einstein's brain. And the question is, was he born that way, or can you make yourself become like that? I'm of the opinion that you can develop it yourself.
You really think so?
Einstein was not a prodigy. I just finished writing a biography of Einstein. It'll come out next year. But I did a lot of research into Einstein's early life. He was not a prodigy by any means. He had the ability, this horse sense, to be able to zero in on simple physical pictures that a child could understand, that would unravel the paradoxes of light and Newtonian mechanics. And so I think he had a keen physical instinct, which can be learned. I think it can be learned. So I think that it's not all genes, okay? Einstein's children were not necessarily exceptionally gifted. One was, in fact, schizophrenic. The other one became an engineer. So I don't think it's genetic. I think you can learn this by having, you know, a lot of mentors when you were a child, a lot of interest, a lot of encouragement as a child. And a lot, of course, a lot of what is called butt power, the ability to sit on your butt for hours at a time, contemplating equations.
Do you believe that the process of natural selection drove was that the engine that drove evolution?
Well, so far, that is the only mechanism that biologists have found that can take, you know, random bits of DNA and create more and more complex beings. We can simulate that on a computer screen now.
Well, there was a scientist, doctor, that theorized the other day. I had a story last week that I found fascinating. People got angry about it, but he said he believes that in the Western world, our part of the world, evolution has ceased. And he made his case by suggesting that we have stopped, essentially, the process of natural selection with all of our modern conveniences and modern medicine. And, you know, we save people who otherwise would naturally pass away. And we have stopped evolution. Would you give some weight to that concept?
Yeah, I think most biologists would say that's correct. Evolution is forced upon you by a change of the environment, food supply. Animals do not evolve because they want to evolve. Animals evolve because they have to evolve because the weather changes and the food supply changes and predators come in. With humans, we don't have to worry about food supply anymore. We don't have to worry about bears and lions and tigers. We don't have to worry about diseases so much anymore. And it means that the pressures placed on humans are simply not there anymore. And so in science fiction novels, you read that humans are going to have big heads, and we're going to lose our hair. We're going to have childlike features, like in a Spielberg movie, right?
Yeah, right.
But that's not the way it's going. What you see is what you're going to get 100 years from now, unless we tinker with our genes, because there's no pressure. There's no selection pressure being pushed on us to make us evolve in one direction or the other, because we do have a secure food supply. The weather is relatively stable until, of course, the greenhouse effect kicks in.
Yes.
And when those extreme situations begin to kick in, then you're going to see evolution, natural selection beginning to come into play. And, of course, natural selection is not pretty. It means people die.
Oh, that's right.
It's not pretty at all.
That's right. We're so short on time. You have talked, I think it was you, have talked about the concept of putting, you know, sort of a 2001 obelisk on a moon, that might be a reasonable way for an alien race to monitor the emergence of life.
They would do it to monitor us.
Have you heard about this recent story about this incredible gigawatt transmission from a very, very specific place on the North Pole of Jupiter? X-rays, massive gigawatts of X-rays that about every 45 minutes issue a burst.
Well, I haven't heard about that. However, Jupiter is an enormous emitter of electromagnetic radiation. It just staggers the imagination how much radiation comes out of Jupiter. Our space probes were practically blinded when they got close to Jupiter, so we have to be very careful. But it's so far the radiation that we've observed is not necessarily consistent with any pattern. You're suggesting that there's some kind of pattern here?
Well, the scientists who just took another look at it, apparently they saw this back in the 70s and sort of just passed by it and came back and took another look at it here recently, and they were using words like beacon and they mentioned ET. You know, it was pretty interesting.
Well,
I mean,
who knows? You know, we have the Galileo space probe orbiting around Jupiter, and we have the capability of monitoring it. So we'd be able to pick up radiation, even though, of course, the Galileo spacecraft is slowly degrading with time. We have the ability to monitor the radiation there. And, you know, the next missions could be focused on Europa, a moon of Jupiter. So it would be very important that we know exactly what the fields of Jupiter are if we put a probe on Europa to look for the possibility of fish or worms that can swim inside the oceans of Europa.
I believe that there's been some thinking that under Europa, not only might there be water beneath the ice, but there might be volcanic heating, and we know that volcanic venting at the deepest levels of our own ocean, why this amazing life surrounds it.
That's right. The most primitive DNA that we can find on the Earth is in ocean vents at the bottom of the oceans. That's the most primitive DNA we can find, which means that could be where life started from. Back then, the Earth was quite hostile. Meteors were hitting the Earth all the time. Oceans were boiling off periodically. The oceans were probably, quite hot in those days. And so ocean vents, these vents on the bottom of the ocean, are now recognized to be the harbinger of the most ancient DNA that we have found on the surface of the Earth.
Wow.
And that may have been where the first DNA got off the ground.
What?
And in Jupiter, we have tidal forces that squeeze Europa, and that, of course, cracks the crust of Europa and causes heating to occur, friction.
Friction is heat.
And that also probably creates volcano vents as well. So the tidal forces caused by Jupiter's gravity is probably sufficient enough to cause volcanoes. And, there's probably volcano vents down there, too, which probably give enough energy to perhaps get DNA off the ground.
Doctor, you said you've got a book coming out. If you were to recommend one book to the new listener who's enjoyed the program tonight, one of your books, what would it be?
Well, Hyperspace, talking about higher dimensions, and Visions, talking about the world of 2020 and 2050.
And, folks, those are all available. If you go to my website, we've got links to all of his books over at Amazon.com. So if you liked what you heard tonight, go read some more. Grab one of those books, Doctor. As always, what a pleasure to have you on the air.
Oh, my pleasure, Art. Anytime.
Good night.
Okay.